Good afternoon, everyone. We're a little early. That's just because there were so many people in chat, so I thought I'd just start. and there was a request made. 1 second. Let's just increase the size of this camera for a moment. See how long the cable is on this. And just hello. She's just looking at all of you with disdain. That's all that's happening. She's just yeah, whatever, humans. Whatever you're doing, not super important compared to what I'm doing, which is just chilling. Okay. Let's get into it. Here we are at lecture number 2 for COMP1511. Good to see a whole lot of people yesterday. I managed to go to both of the physical locations where Lab 0 is happening, but also got a chance to come along to the Discord, although I think I missed a lot of people because I turned up at the Discord reasonably late in the 2 hours, but I still got to speak to some people there, so it's great to sort of just get in touch with people. It's been a year since I taught anyone in person, so it was nice to just at least meet some of the students that I'm teaching, so it was good to meet everyone. If you haven't looked at Lab 0 is something put together by CSE SOC Student Society that just helps people get started with the infrastructure here at CSE, and also just a little bit of little bits of trivia about some of the lecturers and some of the systems and things, and just sort of, it's like an introduction to campus in a way, but from a very CSE perspective. So hopefully some of that information is useful. We are going to be adding a link somewhere on the course website, maybe this afternoon, although this thing ends at 6 p.m. on a Friday, so I can understand if everyone else is going to be as tired as me by the end of this and just switch off until next week. But sometime soon, we'll make sure that the Lab 0 materials are still available so that you can use them. So anyone who already has the link to Lab 0 can use it. I'm happy for anyone to share the link to Lab 0 in chat at the moment if you want to. But we'll put it on the website anyway so people can get access to it, because it's kind of useful little material. Another thing I was going to talk about today, and I'm noticing that, the live chat is super active. And I just want to say something about there's a lot of different levels of prior knowledge coming into 1511, because we don't really have any control over what you've learnt up to this point. So some people have been programming for years, and some people have literally never programmed a computer at all. And I just want to say all of that is fine. We don't have a specific requirement for what capabilities people have before they come in here. So there are going to be, and I've noticed already, there's going to be some people flexing their previous knowledge and skills and stuff like that. I just want to say, look, flexing over other people is a little bit, you don't have to do that. It's fine. You'll be fine whether or not you flex over other people. So just have a care with that. And if you do see people flexing or saying anything that's not the same as what I'm saying or what's in the course material and stuff like that, don't worry about it. It won't be super important. A lot of that stuff, you will have time to learn it later. So if someone else knows it, it doesn't matter. You'll get there. And if it's something, that you're really kind of impatient to learn it and stuff like that, a little bit of that's okay. It gives you kind of a push to look things up yourself and learn things and stuff like that. But at the same time, true learning is done through the patience to actually go through these things. So one of the most important things I think you can do when you're learning anything is don't race people. Because no matter where you go, no matter what you do, this is going to be your whole life. You'll always, if you look for them, you'll always be able to find someone who's ahead of you. And I say ahead because it's how do you even measure that, right? But we always get into situations where we perceive other people to be ahead of us, and then we start judging ourselves against them. And sometimes it's okay. Sometimes it gives you a target to achieve. I want to learn the things that person knows and stuff. Maybe you end up friends with that person because you talk to them about it and stuff. Those are really positive things. But there can be situations where you just look at the people around you and you go, I'm never going to be able to catch up with them. And I want to kind of really hammer this point home that catching up is meaningless. you know, because it's not a race and it's not a competition. We're all eventually going to find somewhere or somehow that we're going to do the things that mean something to us. It's much more important to find something that you want to do that is meaningful to you than it is to have this kind of race of who's got more skill than someone else, because that always ends up being like skill in a very, very slim, narrow idea of what is measured or not. And then there's heaps of things that you can be skilled in that aren't measured at all and can't be measured. They don't have numbers attached to them and stuff like that. And it's really hard when you happen to be good in those things, and it's like, well, you know, someone can be like, I got marks over 90 in everything at UNSW, and it's like, that's amazing. So not to say that's not amazing. That's a lot of skills, a lot of time and effort, and that's a lot of paying attention in stuff like lectures. But other people have skills where it's like, when I work in a team, I said when you, like, you might be this person, when you work in a team, even when your own output's not that great, everyone else's output is better. And people will get hired for that kind of thing as well. So it's those things, you know, it's hard to measure. So the more you start like trying to race against people for like specific kinds of knowledge or marks and stuff like that, the more you might be missing out on some of your own amazing abilities and things that you've learnt. So I just wanted to say that because I think that chat and also forums and all this kind of stuff, everyone's going to be at a different level of ability and a different place in your journey, and that doesn't in any way invalidate anyone's journey. Everyone's journey is valid and will take you somewhere interesting. So yeah, I just want to say that at the beginning, because we're still early on, so we're still early enough that there are people who could get discouraged by just witnessing the capability of people around them and just being like, well, I don't have that. And it's like, of course, none of us need to have that right now. That's why we're here. We're at the beginning of our big learning journey. So you can start from anywhere at this point, and the finish point is going to be, you know, at the end of this journey, at the end of university, is probably going to be not that different between a lot of you. I mean, talk to some of your tutors. Some of your tutors did not code before they came to UNSW, and now they're respected as people who know enough about coding to pass it on to other people. So this is interesting stuff like that, right? Anyway, okay, let's get into the lecture itself. I've got some slides here that we're going to talk about. Okay, first thing, what did we learn on Wednesday? I nearly forgot when it was. I was going to say Thursday. No, Thursday was Lab 0. So Wednesday. So we had our introductions. We looked at the admin of the course. And also things like, do you know where to get help? So course website, obviously lots of information there. It's all split up into different things. It's all written down. Not everyone does writing as how they get information, which is why we've also got an intro video if you prefer listening. There's a forum if you prefer a bit more interactive and actually asking the questions yourselves. Also your tutors. You have two. Everyone's got two. You've got your tutor and your assistant tutor. They're great people to be your kind of first port of call for help. A lot of simple things they can help you with immediately. So if you talk to them in your tute, you have their email addresses as well. Don't spam them. But like, you can email them and ask them questions. So if they can answer a question, you get a very quick response. If they can't answer the question, they'll bounce it up to myself or Tom, the subject admin, and we'll try to help you. You know, so there's always ways to get help. And we also talked about some tips on how to do well in programming. And then we took a more of a deep dive into programming in C. We looked at this brief look at computers and history. And so we're going to be going through this kind of thing where I'm not just going to be teaching you just C programming. I mean, I'm going to be slipping in all these other things to do with what it means to be in computer science. So we're going to do a little bit more of that today, but I have another slide for what we're doing today. We also wrote our very first C program. It was with a Hello World, and the Hello World is really just a proof that the C can run. In a sense, we're going to get more complex than the Hello World even today. But we did get it up and running in Linux. So we learnt that we can write code in the C file. We can run the program DCC, which is a compiler. The compiler takes our code and transforms it into the thing that the computer runs, which is the program. So it's kind of like there's the code file, and then there's the program file. And then we figured out how to run the program file, which is then printing out hello world. So there's a few different steps in there. I always like the baking the cake analogy. So you write the recipe for the cake, which is the C file, and DCC is the act of putting it in the oven. When it's finished in the oven, the program file, which is whatever you named it, pops out at the other end. So you've got these separate files. One's the recipe file and one's the cake. And when you run the cake, it actually does the thing that you said that should happen in the recipe. So that's the kind of process. And we're going to be doing more in that. We're going to be doing heaps more of that. So this will become something that you're familiar with as we go along. But, you know, since we've only seen it once, I thought I should explain it. Okay, so what are we looking at today? In the next 2 hours, we'll be covering a whole lot of stuff to do with programming in C. The first thing is variables. So remember how I split the computer up into two parts? There's the thinking bit and the remembering bit. So the thinking bit is the doing bit that's going to like decide what instructions we gave it are going to run. So it's going to run them in order, that kind of thing. But the other thing was storing information, keeping things in what we call computer memory. So variables are our first thing that we're going to learn about, which is about storing information. And then we're going to learn about conditionals and branching code, which is giving our computer the option to decide what code it runs based on the situation it finds itself in. So it's an ability for us to kind of get our very basics in both of those fundamentals. Okay, like storing information and then choosing how we react to the situations around us. I also have something up now which is the live lecture code link. So I hadn't had that set up for the first lecture. Also, the first lecture is actually in these links. So I have this, not quite a web page. It's not really a web page, it's just a directory that has files in it. This is the actual directory where I'm going to write the lecture code. So when I compile stuff is going to appear there. Don't worry about anything that I compile or the backup files and stuff. The C files in here are what you want to look for. So today's lecture is in a directory in there called lecture 02. And so I'll put the lecture number directories in there. The cool thing about this is I'm going to be writing code today. Every time I save the code, it is going to appear in this directory. So you'll be able to, every time I save it, you can load up this, you can refresh this page, and then you'll just see whatever I've just written. Okay, so a quick recap. Also, don't worry if you didn't write this down or click on it immediately. The link is actually on WebCMS, so the link is in today's lecture section, so you can just go there and click on it if you want to. Okay, a recap of what we did. Actually, I should have changed this because we wrote a new one, and which is in the lecture 01 section in those folders I put there. I should have renamed this because I actually renamed it to made this comment February 2021, I think, when we wrote it the other day. But this was the code we had. So just remembering some of the bits and pieces that go into this. Comments. They will usually be blue in gedit. Depends on what editor you're using, but most of us, I think, are going to be using gedit in VLab. These are things that the computer doesn't read, but that is for us to be able to read, so it's to help our understanding of the code. They're not just going to be at the top of the program, they're going to be all through it as well. We'll do more of that today. The hash include is like grabbing some information that someone else has written in C and then including it in our program. So this is standard input-output. This is just stuff that allows us to write stuff to the terminal, like the hello world that we wrote to the terminal, and also read things that someone types in. We're going to do a bit of that today. Int main void, we will learn more about this particular line later. I'm going to let you know that this is the main function, and this is where the program will run, and everything inside these curly brackets will run line by line, top to bottom. So printf is one. Printf is a specific thing that's used from the standard input-output library, and that just gives us the ability to write things to the terminal. I think at this point everyone's done their tutorials, because I don't think there's any tutorials after this lecture. So everyone at this point has had a go with this. If you haven't been able to make your tutorial this week, check out. You can go to the Moodle and the Blackboard Collaborate, and several of the tutors will have recorded their tutorials, so you can go back and see it again if you need to, and you can still do the lab work up until Monday. So it's not due till Monday 8 p.m. So if you've missed out and you want to do it on your own, you can probably set aside some time this weekend and get that done. Return is a specific thing. We are basically everything that I say that's like a little bit specific that I'm not giving you all the information for. It's because I don't want to just throw everyone in the deep end at the beginning. We will be looking at what the return word means and its sort of ramifications later on in the term. Okay, just making sure that I'm not covering up any text here. Oh. Sorry, I just noticed that I haven't set all of the folders in the live lecture stuff as publicly available yet. So only, as I'm seeing there, only lecture 02 is visible at the moment. So I do have the lecture 01 stuff there, but I haven't set the viewing permissions for everyone to see it, but it doesn't matter. You can see what we need for today, and then after we finish, I'll set it up so that you can see the whole directory. Okay, so let's think about how a computer remembers things. So a lot of stuff that we're actually going to be doing in programming is asking our computer to remember things. It's a funny little thing where it's just like, can you remember this number for me? And I'm going to use it again later. And so everything that a computer remembers with is made up of ones and zeros. If you've ever heard of binary, this is what it is. So the binary numbering system is really, really simple because it only has the digits 1 or 0 in it. Our normal numbering system has 10 digits, which, strangely enough, comes from us starting to learn to count on these, which is why our numbering system goes from 1, 2, 3, 4, 6, 7, 8, 9, and there's a 0 in there that we use to represent the tens or the multiples of 10. Computer memory is like a whole bank of on-off switches. Like, that's basically all it is. That if we were to look at it under a nanoscopic microscope, a really, really small microscope, in stuff like memory chips. I'm pointing at my computer over here, you don't need to see it, it's fine. Memory chips and stuff like that just have a whole bunch of little switches that you can flip one way or the other to a 0 or a 1. We call these bits, and that just means like it's a single thing that could be either on or off. And we usually collect these together into collections of 8 bits at a time, and we call these bytes. So you get this really, really funny, confusing thing that happens when people like sell you computers or sell you an internet connection or something, like, because internet connections are generally measured in megabits, and that's like how much data per second goes through. And then you'll buy a hard drive and it's measured in megabytes. And it's weird because the numbers don't match up because one of them is 8 times the other. So if you didn't know that before, now you know the difference between the bits and bytes. So when we're working with memory, we're going to be fiddling with memory of different sizes, and it's going to be made up of a certain number of bits, which also means it's made up of a certain number of bytes. It's just that 8-to-1 ratio. So when you're hearing things about computers, you may have heard of things like 32-bit and 64-bit systems. So 32-bit systems still kind of exist, but most everything has gone over 64-bit systems nowadays. And that's just we're going to look at this later, that's the ability for the computer to use a certain size of number to be able to reference things. I'm not going to say anything more about it. We're going to talk about this heaps later. But for now, we need to build up the simple things, and then we get to the weirdness and the complexity of these kinds of things later. So, a variable is the first sort of programming concept that I'm going to teach you that's going to be with you forever. I don't think, I can't be sure of this, but I don't think we're going to be removing variables from programming in the foreseeable future for the next, I don't know. I don't want to put a number of years on it. Let's say 50 years. I still think we're probably going to be using variables in 50 years' time. Who knows? We have some epic quantum computers that shake everything up, and we'll see what happens then. But for now, this is one of the most fundamental building blocks for how do we work with a computer. So a variable is us basically saying to the computer, can you remember something for us? So I want to store some information in your memory, and I'm going to come back to it later. But it's called a variable because the word means it's changeable, which means we can change its value. So a variable, if I ask the computer to remember a number, I say, remember the number 7. And then I say, you know that thing where I told you to remember the number 7? Can you add 1 to it? So now the computer says, yeah, sure, I can do that. I'll remember the number 8 now. And when you come back to it, it'll be the number 8. And then you can say, all right, multiply it by 2. And it'll be like, cool, I can now remember the number 16. So it's that kind of thing where we say, I want to keep track of something, and I want the computer to keep track of something. That's what a variable is going to be. And so in order to do that, the computer, its only memory is made up of bits, right? Zeros and ones. So it will use those zeros and ones to represent the number. And that is the kind of binary numbering system. We're not going to go into like super exhaustive detail about how binary represents numbers, but you can kind of think of it the same way we represent numbers, where if we have the digits 0 through to 9, we go, okay, count upwards through those, and then when you get past 9, you have to add a new digit, and so there's a 1 and a 0, Binary is even more simple, where it's like, okay, we've got a 0, and then we've got a 1. Once we go over the 1, we move to the next digit and add a 1. And then it can just kind of go along like that. But it's capable of representing the same numbers that our base 10 number system is. Every time we make a variable, though, we also have a specific purpose for that variable in mind. This is what's known as the type of the variable. From the beginning of the course, we're just going to look at 2 types of variables. One of them is an integer, and the other is called a double. So the integer is a whole number, so no fractions, just whole numbers. And this is something that you can think of as something that we would count quantities of things that can't be split up. I'm just trying to think about what that would be. I was going to say like people. So you have people or not people, and you don't really want to cut people in half, so we think about whole people. Should have thought of that analogy before I said it. Anyway, but double is something like a floating point number. So we call them floating point numbers because they have a decimal that just sits somewhere within the digits of the number, and we don't know exactly where that decimal point's going to be, so it's kind of considered to be floating somewhere in the number. So that's when we're looking at decimals, fractions, and stuff like that. Here's a little bit of the number pi, which you may have come across if you've worked with any circle maths. I'm pretty sure everyone's come across the number pi if they're here at university doing a computing degree, because I think one must have done at least basic, I think this is like very early high school level maths to be able to understand that pi is a number. I mean, it's obviously a very complicated number, but we know that these are parts of numbers that can't be represented in these integers. So we're just separating our 2 types into quantity numbers versus numbers that have fractional parts. Now we get into like the more computer sciencey side of things. A reminder from Wednesday, we have our coding and we think about the code that we write. Half of our code's for people. So every time we create a variable, we're going to be giving it a name. So this is a quick hint for your own future. And there is a future for all of us where we've written a program and we don't understand what it does. And it's deeply ironic because we wrote it. There's a meme, I think it's at the very end of the course, but it's quite funny. Hopefully you'll remember it after I say it now, and then you see it again at the end of the course. And the meme is debugging code, or just like being a programmer is like being a detective in a murder mystery where you're also the murderer. So it's like we write code and then we hit a point where we don't understand it that well. And so naming your variables with really, really clear ideas of what this thing is going to be used for is a very good way of doing it. So if I need an answer for something, I could call the variable answer. If I'm doing maths on a circle or something, I could call something the diameter. A lot of people get into like this really old school, it's like a 1980s style of programming where they put just the letters A and B in for their variables, and it's like, oh, A is the answer and B is the diameter, and it's just like, why didn't you just call them that? Because when you're deep in your code and you're like 1,000 lines into your code somewhere, like we do end up with like thousands of lines of code, and you just see a B and you're like, what is B? And you're like, I've forgotten. I don't know. And then it makes it much harder for you to figure out what's going on with your code. So we're going to try to name our variables with the idea of the purpose of the variable. Because if we ask the computer to remember something, it's usually because we've decided there's a reason we want the computer to know something. So names are always important. We are always going to use lowercase letters to start our variable names. It is technically possible to create a variable with an uppercase letter, but what we're trying to do here is try to adhere to a kind of a standard so that when we scan through things we can see really clearly whether something is a variable or whether it's some other programming construct that we've created. Now, for the moment you don't know any other programming construct, so it's not that big a deal, but later on it will become a big deal. So we're always going to have a lowercase letter for our variable names. And one thing to remember, C is very case sensitive. C is very, very precise in how it reads things. So if you have the variable called answer and you accidentally type it in as answer with this giant W here, C is going to see these things as completely different things. It's going to say one of these is the variable called answer and the other one is this other variable that you've created, or maybe you haven't created and you're trying to access it by accident. C will most likely throw an error if you have a typo like this in your code. So this is the kind of thing where we're going to start to get to grips with the fact that we are communicating with a machine, and contrary to all of the fun sci-fi that we have out there, the machine's not smart enough to pick up on our mistakes like this. It's just going to be really literal about it and say these things don't match. There are other words that you can't use for your variable names because they're reserved in C. So some of these are like return, int, double. So we've seen these as like, these are the names of the types, and I'll show you how to use them in a second. And return we've seen as like when you type in it and it gets highlighted in a different color. So that's a word that C says, no, this is my word, and it has a really specific meaning. You can't make a variable with this name. Like, I'll have problems if you try to do that. So if you ever type in a word and you want as your variable name and it comes in a color, then be like, oh, okay, this must be some kind of programming construct that Mark hasn't taught yet, so I've got to be careful not to use that as my variable name. So plenty of words you can use for them though. When we split words, every now and then there's an issue. We're not using that one. There's multiple ways of doing this, but we're actually going to lock to one particular way of using multiple words in a variable name, which is going to be this one, where we just have the words with underscores in between them. Now, it's a reasonably easy way to read them because the underscores look like spaces. So if you need multiple words for from a variable, this is the way we're going to format them. Okay, so the two, yeah, Jack's one of the tutors who's helping mod for us today in the chat, so he'll be answering as many of your questions as he can, unless you flood him with questions, and then he'll be in trouble. Blake saying they like camel case there. I do actually instinctively write camel case because that's the first one I learned. So these two types of cases. Don't worry about this. Not important for the course. The only thing that's important for the course is we're going to use this anytime we use multiple words. There's names for these kinds of things. This is called snake case because it goes down. And there's other one where you use capital letters for things. It's called camel case because there's humps in it. But we're not really worried about that. We're just going to use one. And this is the kind of thing we're actually going to get to a lot when we're programming professionally and stuff like that, is that an organization that you're working in, research group or a company or anything like that, is just going to pick one way of doing things, and you're going to learn that one way and then just slot in with them. I'm going to talk about this later, but we do have what's known as a style guide, which is the suggested way. Some of it's more than suggested. Some of it's like, we're going to take marks off if you do these weird things. And so what we're basically trying to do with this is to say that we have a way of doing things that's going to teach you the best things you need to learn in this course, and we're locking it down to that. So there's a lot of people who may know other ways of doing things in C and other programming languages. That's fine. It's cool that you know that stuff, but it's not necessary. And it's also, if we're trying to get you to, the whole thing of education is we're trying to get you to walk a particular path, because we know that the things that you see on that path are the things that are going to be really helpful for the future. So that's why we're constricting it, to make sure it goes that way. But that's for a later lecture. We talk about that later. Okay, so the first variable type that we're going to be working with is this thing called an integer. It's reasonably simple to work with because it's a number and there's no fractions or anything like that. So it's just like, it's a quantity, it's a count of something. The most common amount of memory that's used for this, the number of ones and zeros used to represent this number, is 32. 32 bits for this number. That happens to be 4 bytes. So remember that 8:1 ratio. Don't get too caught up in converting everything between bits and bytes. This is just a practice thing. You'll get there eventually, because it's not a super hard numbering system, but then also it's just easy to make mistakes with. So give it time. It'll come with time. So if I have 32 bits, now we're getting into maths. So how well do you know your maths? If I have 32 switches that I can flick on and off, how many possible combinations are there in those 32 switches? Because each one is 2 possibilities, and there's 32 of those 2 possibilities. That means the number of different things that we can show with 32 bits is 2 to the power of 32. And that's good, because 2 to the power of 32 is a gigantic number, which means that we can reasonably represent most of the numbers that we can think of. The thing that we do need to think about this is the maximum. These are the exact maximums. I'll talk about that in a second. The maximum is very large, so we can go in either direction a very, very great distance, but they are not infinite. So once we get beyond, and I've written the numbers out here, because I don't memorize these. I'm not going to memorize these digits. But if we go off the end of these digits, then we have a problem. Most everything we do in this course is never going to approach these numbers. Right, we'll keep the numbers somewhere that's manageable and understandable and closer to this 0 area here. But it's good to know that these things can go beyond. So if you want to do the maths on these with 2 to the 32 different possibilities, if we go down to negative and we go up positive and we include the number 0 in this, we have 2 to the 32 different possibilities. So it's 2 to the 31 in one direction, 2 to the 31 in the other direction, but we have to take 1 away at some point so that we can fit in the 0. So that's how this number line here of the possible values of an integer is a total of 2 to the 32 different possible values. Not super important for you to fully understand everything that's going on in this slide, other than to remember these are whole numbers, 32 bits worth of memory to store them. The maximum is very large, but not necessarily infinite. The other thing is a double. And it's funny because it's a floating point number, but it's called a double because it is 64 bits. So it's called this because it's twice the size of the integer. We use the double, and we use this this number that has more possible values in it, because when you start to put floating points in things, you need more data to be able to be really sure that you've got a good kind of detail level on that number. So the more decimal places you can go to, gotta make sure I'm visible in the camera. The more decimal places you go to, the more sure you are of how exact that number is. So the double's a 64-bit number, and it's a floating point, which means that, see these digits here in these two numbers are exactly the same, 10567 in both of these, but the point is somewhere else, and that changes what these numbers are drastically, because this number is not really anything like this number. This one's approximately 10 times that number, and that's because the floating point is somewhere. So there's a bit more information in these that says where the floating point is. Once we start using these things, we're really just going to be like, here's the number, computer, you remember the number. But it's good to know a bit about what the background is behind these. So the double is 64 bits, and the integer is 32 bits. We're not going to go too deep into exactly how they're used based on their size and things like that, but it's handy to know. When we're actually making our variables, we will be writing specific code that allows us to use them. So the first thing that we need to do, if we want our computer to remember something, we have to tell it what it's going to remember, and we have to tell it how we're going to identify it. So if we're going to ask for it again, it has to have a name. And that's what this line here is, and the comment I've put in here is this is declaring a variable. I'm pretty sure all of this code, I think I have, on the web page. I've put all this code on the web page. There's a demo of the variable code there. So This we call a variable declaration. So we declare a variable first by saying what type of variable we want. At the moment we have two options. We have an integer or a double as our options for which variable type we're going to use. By the time we get to the end of the course, we're going to have, I don't know, because of a lot of different combinations, probably about 10 to 15 of these different things that we can create as variables. And we're going to have types of variables that are really custom. You can customize them yourself and things like that. But for the moment, we need to learn how to use them before we start, like, you know, making 18 different kinds of these things. So for the moment, ints or doubles. They're all numbers. We're going to do the first part of the course just working with numbers because we need to learn about how to control the program flow and how to kind of control the data as well. And we can do that just with numbers. We don't need all this other information yet because we're going to learn the basics with this. So, int answer says, "Dear computer, I need you to remember a whole number for me. You're probably going to use 32 bits for this, but this is up to you, not me. I'm not really defining this." So, things like ints and doubles for the moment and for the duration of this course, they're really set in stone. So, if you're working on our systems with our compilers and stuff, the compiler actually makes these decisions. They're going to be 32 bits for an int and 64 bits for a double. I have no guarantee to say that sometime in the distant future, C gets updated and these things are not the size they are now. So maybe an int is 64 bits and the double becomes 128 bits or something. I don't know. That's up to the people who actually control and write the C language to decide. But anyway, I'll say to my computer, I need an integer, I'm calling it answer. Computer will say, all right, I'm setting aside 32 bits of information for you. I'm going to tag that so that I know that anytime that you write the word answer, I'm going to know that those are the 32 bits of memory that I'm going to use, which has your number stored in it. When I declare it like this, there's no number in it yet, right? So there's no information in there, but it's ready to take information. The first time we put information into something, we call it initializing. And so I can take the number 42, and I can say, put the number 42 into answer. This is where we get to one of the first crinkly bits of C. The equal sign, and everyone will probably know the equal sign. I say probably, I hope everyone knows the equal sign. Because in mathematics, the equal sign means that both sides of this are the same. So either it's a hope that both sides will become the same, or it's a question saying what is one side equal to. In computing and in C, the equal sign is actually a little bit different like that. It's not a question, it's actually an instruction. So in the same way that I said every line in the main is an instruction, something we're going to tell the computer to do, this first thing says, I need you to set aside enough space to remember an integer, and this is its name. This is actually a command. This is something we're telling the computer, and we're saying, you know that thing answer? Make it 42. So we're saying to it, can you store the value 42 in the memory where we said answer is? So it's kind of like, this is a number. We've asked the computer to remember a number, and we said, okay, the answer that we asked you to remember, make it 42. And it's like, cool. The computer's like, cool, 42. Good. I'm not going to forget that. If your computer does forget that, there's other problems. It's like, I don't know, cosmic radiation has flicked your memory somewhere and stuff. But otherwise, we're going to rely on the computer to remember this, because computer memory is much better than human memory. It doesn't forget little things. It is a variable, though. And being a variable means that it's not set in stone as 42. So I can say, all right, now that I've thought about it carefully, could you make the answer something else? Can you make the answer 7? This can get really much more complicated, because here where I've written 7, I could have a whole mathematical equation here, and then that could change the number in many different ways. We're going to look at the maths later. If we want to, we can declare and initialize at the same time. So I can say, here I would like you to remember a number, and this time it's another answer, so I've called it answer 2. It's hard to name variables when the program has no context like this, but I've just named it answer 2. And on the same line as me saying, set aside the memory for an integer to remember, can you make its first value 88? And the computer's quite happy to do that. It goes, okay, this is the first value, and I will remember it as 88 until you tell me something differently. So that's kind of how we do that. Oh, you notice here actually, this int main, I didn't even put the return at the end. C is smart enough if we don't put a return at the end of our main to actually still go, all right, we think that that's where you wanted to end the program and it still ends fine. That's a little side note from Wednesday. We also have the ability, and this is something that comes out of the standard input-output library that we hash included here in our code. We're probably going to hash include that in, I'm going to go out on a limb and say every program we're going to write in COMP1511 is probably going to include this library, because it's really hard to write programs if you can't see what's happening inside them. Okay, so if I want a number to appear on screen, so when I said hello world before, instead of hello world, if I wanted to say the number value that I have is equal to such and such, I can do it like this. So I have my variable here that I've declared and initialized. So I said the declaration is saying I would like to store a number, an integer, and I'm calling this one number. And I would like to store the value 7 in that piece of memory. So number is now 7. I can then print this out using printf. So printf we've seen before, just to print stuff. But now we can put this weird symbol in here, this %d, anywhere in the sequence of letters. This is it's called a string in computing, but we'll get to that later. The string of letters here, I can put this %d anywhere in here, and that leaves a marker point somewhere in those letters that says this is going to get replaced by something else. And then I put a comma after the quotes that I've had here, and then I can put the name of the variable, and this %d, this %d in here, clicked by accident, will match up with this variable, and whatever value, whatever number value was in here will get put in where that %d is. So what we do is we say, okay, this is the way I want to write my thing, and somewhere in here I want to put a value. But because I don't know necessarily at that point in time what that value is, I mean, in this code we know because we can see the 7 here. But what we're doing is we're thinking about it as the programs run step by step, line by line in time. And at this point in time here, there might be a whole bunch of other stuff that makes number change to different things. But at the point where we reach this printf line, number will have a certain value. That value will replace the %d here and get printed out. So we'll show this kind of stuff in a moment. We can also print more than one variable, and so if we want to print more than one variable, we'll have 2 of these %ds. So the %d just says, I wonder if I didn't write it here, but I think it's in one of the later slides. The %d just means decimal integer, which means that it will take whatever values are in these and print them out as decimal integers. So decimals, base 10 system is the decimal system, and that just gives us the numbers that we recognize. Otherwise, if we wanted to, we could print them out as binary, but it's really, really hard for humans to read binary because we haven't spent, I don't know, I'm looking at, everyone spent about 15 or more years of their life reading numbers in the decimal system, so if we're going to present stuff to humans, we should probably do it in the decimal system. Yeah, so if we want to have more than one number, we can put these %ds in here, and then we can put multiple variables after the string of letters here. And what these will do is the first one will match up with the first %d that it says, and the second one will match up with the second one. We can do this with like a very large number of these. I was going to say any number, but I'm sure there's a limit. But we can do it with a very large number of these, and so we could list out 10 numbers, so long as we put 10 separate variables in here, all separated by commas. So they will match the symbols in the order that they're listed after the text here. We also, this is where I had the decimal integer thing. There's an interesting question there from Ryan. What is printed if there are 2 %ds but only one variable listed afterwards? I think you should try that out. It'll be interesting because I'm pretty sure that's going to give us an error where the printf will say, I had another space for a number. You told me to set aside a space for a number, but then you didn't give me one. So I have a feeling that in the compile step, the attempt to translate from the code that you've written into a program that can run, it'll say, I have no way of doing that. But I think all of these things, and this is going to be great. This is the advice I give you nearly all the time when you ask me, what happens if we do this? My answer is nearly always going to be, what happened when you did it? Right? Because I think one of the best ways to learn about code is explore. And wise words of someone who was teaching me painting, not programming. They said, "What are you?" It was really funny. It was actually kind of aggressive. It was like, "What are you afraid of? The paint can't hurt you." And it was like, "Huh, hey, they've got a point, you know." Most of the time, not all the time, but most of the time, the worst thing that can happen is your computer crashes and you have to start it up again. But nearly everything that we can do, my suggestion is try it, see what comes from it, and then decide whether you want to use it or not. Plenty of times when I say that to people, they'll try it and they'll say, "Haha, my program completely broke when I tried that, so I know what not to do now." And it's good to do that. Learning is about exploration, right? So you're exploring where the boundaries are of what the compiler will or won't allow you to do in code, and then you can discover for yourself ways of doing things. When you get through this exploration and things, you can then also talk to someone like your tutor and say to them, "So I was trying all these random things and this came up. Is this the way that this is done?" And they will probably tell you, it's like, "That's an interesting exploration." Plenty of things that you can do. They're going to say, "I have no idea what you did there." Because a lot of us, once we've learnt like the proper way of doing things, we forget that there are other ways of doing things. But they can help you find a way that is going to work well and doesn't have any risks for you to use it, and also is a way that's going to be memorable for you to be able to keep doing it. So those discussions are always very good to do with your tutor. Okay, so previously here we were only printing out integers, but we can print out doubles as well. So anything that is stored in a variable should be able to be displayed on screen in some way. Sometimes it's more fiddly, but for the moment it's not too fiddly. We have two different types of symbols. The %d is decimal integer, that's why there's a d in there. And the percent, this is really awkward because the %d is for integers and the %lf is for doubles. So it's really kind of, we have to go through this whole history lesson with C to know why these things ended up like they did. But the d for decimal integer will print out these integers. So the diameter here being an integer gets a %d, and then we want to print out pi here. We use the %lf, and so this whole combo of 3 characters now, you know, like the /n, which you should have seen in your tutorials a fair bit now, is 2 characters that we type in here that ends up 1 kind of key press in the terminal. This is %lf, so it's 3 characters that all gets replaced by 1 variable value, but it also gets replaced by lots of characters anyway. So the %lf says I'm expecting a double, a long floating point number, so they call them long when they're twice the size of the standard size, which is the 32-bit variables. It's a lot of fiddly kind of knowledge here, not super important to learn or understand. The important bits to know are the %d symbol is for the integer, the %lf symbol is for the doubles, and it will be able to print out these values and you'll be able to see these values. We're obviously going to go through examples of this stuff. There's going to be examples in your tutorials and labs where you learn how to work with all these things. Ryan said they were able to confirm that this does not let you compile. So it's good. That means you know the DCC is helping you. It's saying, hey, if you wanted to print out 2 numbers but you only gave me 1, I think there's a problem. You need to go back, rewrite your recipe, and I'll bake you a new cake. Okay, the other thing we can do is we can also read information from our user. Our user can actually just type in the terminal, users who is running the program, right? Like me when I'm running it, or like you when you're running it. Or later on in life, when you have created a program for other people to use, it's the kind of thing that you give to people, right? So the user can then type something in, and Scanf is the function that does that. Scanf looks reasonably similar to printf, but it's not exactly the same. But it uses these same pattern symbols. So what I can do here to read an integer is I can say, I've set up an integer. So I have the space in memory in my computer that says I can store a number. And we need to do that first because we can't read what the user's typing in without somewhere to put it. So we could read it, but then if we can't remember it, it's not really any use to us. So we have the variable that we're going to store something in. And then here's something for our human user where I've said, hey, can you type in a number? And this way the user knows that they're about to be asked to type in a number. And so after this prints out, there's a cursor in our terminal, and then the program will just wait. So the program will actually stop running at this point until the user types something in. So they can type in a number here, and when they press enter, it goes into whatever variable is afterwards, this input. And then you might be asking me, hey, what is that and symbol there? Why is there an and symbol before the variable? The reason for that is, if we ever used the variable on its own without this special symbol, what we get is just the number value of the variable. At the moment, there is no number value there, but this would actually transform into the number value without that and. That and actually tells us we don't want the number value here. We're looking for the actual variable location. We're looking for where you decided to store these 32 bits, and that's where we're going to put this number. I'm not going to go into too much detail in that. I think at this point you can just say, if we want to read a number in, we're going to use the and thing. Later on, we're going to do a deep dive on these things, and we're going to fully understand what this and is, but we're not ready for it yet. So we'll get there, I think, it's either week 5 or 7 that we'll get into that, but not yet. Too much stuff at once. As it is, I'm throwing a lot of stuff at you today, so just for the moment, just use it as it is. And if we're reading a double, we can do the same kind of thing, where you note that it's just this percent symbol here that decides what the input will be read in as. So if you do %lf as a scanf, then you're expecting the person to type in a number that may or may not have a decimal point in it. Because if someone types in a number that doesn't have a decimal point, that's easy. The decimal point just goes on the end. But this means that it can handle a decimal number, whereas the %d won't handle a decimal number. And we can put this in its variable, right? So this is kind of the standard layout for how we will read a number from our user and store it in a variable. So now we have the capability to show variables, and we also have the capability to read variables. Another type of, I guess, number storage that we might use, and it's not just number storage, we can store other things in these, what we call constants. You probably have seen the idea of constants in mathematics. They're things that, they're numbers that aren't going to change. We're not necessarily only going to be using the numbers, but for the moment, when we're using only ints and doubles as our variable types, most of the stuff we're going to store as numbers. So it's called a constant because it's not variable. It's not going to change, so we can't call it a variable if it isn't variable. And these go under a very different system to the variables, because our variables, we say, hey computer, can you get a piece of memory so that we can use it and we can change the values in it. And that's why it goes in as an instruction. The constants are actually defined, and defined is a hash command that happens outside of our program. And what that does, it actually talks to our compiler, and it basically says, I want you to remember this number, and then anytime I use this word, replace it with this number. So it actually it's nearly like it's going to go through your code and look for these letters anywhere in your code and replace them with this. So that's what the hash define is going to do. It doesn't actually store any memory. It's nearly happening at the making the recipe level rather than after the cake is cooked and actually runs. I don't know if that analogy is like sticking with everyone yet, but thinking about the process of when things happen is handy. So the reason we might use constants is we have a number that we think is not going to change through the course of our program running, and we want it to be really clear that it's not going to change. And so we even change what we did in terms of like variables. When we had variables, we were doing it with lowercase letters. When we're doing it with constants, we do them all uppercase. So we do all caps like this. And so if we're doing all caps like this, it's really clear when we're reading our code later which numbers we can change, which numbers we can't change. So these numbers are numbers that we consider are unchangeable. And so I used things that, like, according to physics and maths, are not changeable. So the speed of light and the constant pi. I was going to call it something else, and I realized constant's the perfect name for it. It is a mathematical constant. This is pi only to... Oops. I keep clicking on things as I'm trying to point at them. This is pi only to a certain number of decimal places. Also, I think The speed of light might be more exact than that, but you know, when we're doing stuff in computers, we have to accept a certain amount of approximation of things like that. I mean, we don't know the exact value of pi anyway, so it's not like we can say that there is an exact value. Humans have been using an approximation of pi for our entire history of mathematics. But this structure is something that we're going to be using to store a value that we're never going to change in our program, and we want to make it clear to our user that this is never going to change in the program. Oh, sorry, not to our user. Make it clear to ourselves and other programmers that we're never going to change it during the course of the program. There's actually more stuff about constants, but I'll teach you that later. They can come in really handy for other reasons as well. So I said before, you know how I was talking about assigning a number value to a variable? We can do that with maths. So if I want to do any maths in code, it's really, really similar to just writing out the maths as it is. We're limited a little bit in terms of how we can draw it. So we're limited to symbols that we can find on our keyboard. So if you're doing maths by hand on paper, you're going to put fractions over and other things. We can't do that when we're typing things in code. So our division is just a slash between things. We're also definitely not going to use the X key as multiplication, so we use the asterisk for that instead. But otherwise, everything that's happening in the maths is going to happen the same way that you would expect it to happen in maths normally. So these operators can be joined together in multiple ways. They will follow the normal rules for the order that happens, as in multiplication and divide will happen before plus and minus. Unless, of course, you use brackets. So you can use brackets to control your maths as well. So we've got 5 and 10 here, and we're saying x plus y. That would be 15 multiplied by x. So we should get the result 75 out of this. I just did it on the top of my head. I'm pretty sure, yeah, 15 by 5 is 75, yeah. Again, there's this funny thing that happens to you. If you use computers to do all of the low-level thinking for you, you start to forget how to do it. So my ability to do maths in my head, I think, has just kind of gone over the years. And so I just did that multiplication in my head and was like, am I right? I don't even know. I would run the program instead. So a lot of the time this is, this is the future of us as humans, where we actually rely on computers for a lot of things that we do. And then we think about certain things, we get our computers to think about other things, and we become, more capable of doing more difficult things because we've offloaded some of the abilities to computers. I do have more detail in the next few slides about variables and the way they're set up and stuff, and I just want to say to everyone, this is like exactly what I was saying at the beginning. None of this stuff is super important. It's a little bit important, it might be important later, but this is why I throw this at the end of this section rather than during the details on the actual variable. So let's have a look at some of these interesting bits and pieces. So integer issues. There's some really interesting stuff. You know how I said there's a limit? So there's the upper end, hang on. There's this upper end, the highest value, which is this one. And there's this lower end, this lowest value, which is this one. So what do we got? Thousands, millions, billions. So it's about 2 billion as the maximum and about 2 billion as the minimum. One of the weird things that happens with integers is the way that they're added together or whether they're subtracted from each other. If we add two integers that are large enough together, they go over the maximum value, and it doesn't even throw an error or anything. All it does is it goes off the maximum and then just comes back in off the minimum. So it's like, I don't know if you've ever played those computer games where if you walk off one side of the screen, you just come back on the other side of the screen. Makes no sense at all, but it's just kind of funny. This is me looking at my camera feed and making sure this all works, right? So you can have this thing called overflow and underflow, which means that if you're working near those boundaries of the maximum and minimum, you have a chance of going over. If you go over, it flips all the way around to the other side. You want to look at possibly the worst example ever of, I can't remember if it was overflow or underflow. I think it was overflow of an integer. The Ariane 5 rocket. I think this was 1980s. It was a I think this was the first launch of a new rocket built in France, and it was like the thing was built well. There was nothing wrong with it, but there was an error in the telemetry software that was working at that allowed an integer to roll over. And it rolled over, so this thing was telemetry, so it was like the rocket's going vertically, and there's all these slight turns in the rocket, and the rocket's correcting it. And then it got past a certain point, and the number in one of the calculations went over for overflow for underflow. And so you went from these slight changes in direction to suddenly having this massive negative number somewhere in the code, and the thing basically tried to take a right angle turn in mid-flight. And if you know anything about those big rockets, they're not going to make that kind of turn. They're not like a bicycle that you can just do a turn or something in. So instead it broke itself apart and blew up. So this error, like, we think that we can't do that much damage with code, but we can blow up some really, really big things if we're not thinking carefully about how our code's going to work. So that's just something to think about. Also, 32 bits is something that I'm saying that we're going to be using most of the time, but different operating systems may use integers at different sizes. So we can't guarantee that we're going to use it like that in this course. Doubles have their own issues as well. We don't have infinite precision with our doubles. We have a good idea of what the number is, but we can't, like, there's even some numbers that are reasonably simple, like 1/3, that we can't encode to perfection in a sense. We can encode to a very close level of the idea, but not necessarily the exact value. So the more bits that a double has, the better precision it has, but it's never going to be entirely perfect. And so a lot of numbers that we represent with floating point numbers are going to be approximations of a real value. And the more times we approximate a real value, and then the more times we multiply that with other things, and then the more times we use it, the more likelihood it is that those approximations start to build up into worse and worse errors as things go in. So something to think about. You won't have to worry about this in this course. Like, neither of these things is probably going to come up in any of your programs in the course, unless you try. You can overflow an integer pretty easily. I've given you the values before that you could overflow with if you wanted to. But yeah, this double precision is not likely to come up too much, but it's good to know, because the more you use these things, the more important it becomes that these are correct. Someone looked it up for me. The Ariane 5 disaster, 1996, and it was $7 billion worth of rocket in a space program that they blew up. And it's really awkward because there have been a whole bunch of engineers who are working really hard to make that thing work really well. And it really sucks that a part of it that was actually really easy to change and really easy to test is the bit that broke it. Because it's really hard to test, like, the propulsion system on a rocket, because you've got to put, I don't know, millions of dollars worth of liquid oxygen to those things to make them fly. Whereas the code for the telemetry is something that could have been tested without costing that much money. This is unfortunate. The thing in that particular case was it worked really fine in the previous rocket because it was a smaller rocket, so it didn't overflow the numbers. Anyway, let's keep going. Division and variable types. So when we have our variable types, our doubles and our integers, when we divide them, the result of the division will be of a type. So it's either going to be an integer or a double. So if we divide an integer by an integer, we're going to get an integer as the result. The weird thing about this is if I divide 3 by 2, and these are integer variables, or even integer values, if I don't put any decimal points in these, and I just write the numbers in my code, my computer's going to go, oh, these are integers. It will not return 1.5. So 3 divided by 2, we know if you take 3 and divide it by 2, it should be 1.5. We're not going to get 1.5. We're only going to get whole numbers from integers. And the downside to this as well is if there's a fraction in a value you try to put into an integer variable or use an integer value for, it will just drop the fraction. So it's not going to round it nicely, and it's not going to make it fit. So even if it's like 9 out of 10, it's just going to be 0. So any fraction will end up in 0. So this means that anytime you do a division with integers, when you think about dividing, if you do a division with a remainder, the remainder is always dropped. It will never give you the remainder. If you want the remainder, you can use this other thing called modulus. Now, mod is something that comes up heaps in computer science and is used less in maths. I mean, it is a mathematical concept, but not everyone will have seen it. This mod doesn't do the division, it only gives you the remainder. So, the 5 divided by 3 will give you a 1, because 3 goes into 5 once, and the extra bits it doesn't know about. But if you do 5 mod 3, you will get 2, which is the leftover when 3 went into 5, in a sense. So we got 1 3 out of the 5, and there were 2 left. Mod will give us the 2. We're not going to look at that in huge detail at the moment, but I think next week we'll actually use it, and I'll do another slide on modulus to like go into the details of it. People are asking questions. I think people are like just talking about the different the details on the division and stuff like that. Okay, so break time. Okay, I'm not cutting off any text there. So we'll take 5 minutes, and then after that we're going to launch into some code. I'm going to teach you about conditional statements, and we're actually going to write a program as well. So just in the break, things to think about is what is our code? And this is the difference between what's in our code and what's in a program. So our code is a series of instructions that is going to get translated into something by our compiler for our computer to do. The instructions are largely going to fall into 2 categories. One of them is please store this information for me. So this is going to be stuff that we're doing with variables. So either it's going to be like, I need a new variable, or I want to change the value of a certain variable. And some of them are please perform a task. I mean, you could really think about all of those things to be performing a task. Every single line of code asks our computer to perform a task. But we can kind of separate them into categories of stuff that changes values and stuff that actually does some other thinking. Just like a cooking recipe, when we start cooking, we'll do the first things first, and then after we've done things, we do things with those other things. So it's pretty vague, but you know. In our main, we will always start and we go down line by line through our code. There may be things that will allow us to jump around, but I will teach you them piece by piece as we go along. So let's take 5 minutes. It is 5 past 5 now. We'll come back at 10 past 5 and we'll launch into some more stuff with C, as well as writing a program to demo some of the stuff I've shown you today. Hello. I came back early because I saw some interesting questions popping up in the chat, actually. Just going to shut my window. I saw some interesting questions popping up in the chat, and I was going to type answers, and I thought, oh, it's quicker to speak. So Hussein was saying, if integers are so tricky, why don't we just store every number as a double? It's very much a computing efficiency sort of thing, where the double involves storing a bunch of extra information for stuff. Ricardo's like, Mark was lurking. Yeah, well, you know, it's my stream. I'm always going to be here. Although I did walk away for a bit. I do need to stand up for a bit and you know, chill for a bit in between talking. But yeah, so if we don't need the floating points, it's a bit weird to use them, you know? And as we get deeper into computing, we get into this idea of trying not to waste things like memory or processing capability and stuff. In COMP1511, we're not worried about that stuff. We're worried about learning how stuff works. But later on, we start to be really more careful about doing things in the most efficient way. And there was another question about the max and min value of integers and stuff like that. The 2 to the power of 31 in either direction was the maximum or minimum values that can be assigned to any integers. And in terms of the number of integers that we can create, the number of integers we can create in our program is actually based on how much memory we have to store them in. So each integer is going to take 32 bits of memory. So if we have, just waving at my computer again, 16? 32? I can't remember how much memory I have in this computer. I think it's 16 gigabytes of memory. You now know enough about these things to be able to say how many integers can be stored in the memory on my computer. Now, assuming we haven't used any of that memory on things like running our operating system or running our program itself and stuff, I think someone could probably just do some maths right now and say, what is the maximum number of integers that can be stored in 16 gigabytes of memory? Because you know it's 32 bits, so it's actually just a simple division. This one I can't do in my head, because I always forget how many bytes is a gigabyte. I think it's a billion, but it could be more. Could be a billion. I don't know. I have to look that stuff up. But yeah, so now that you know enough, you know how to understand that. Okay, someone was asking for music in the break. Download more RAM. Oh, so there was an interesting one from Cameron there saying, our computers are so fast anyway. Let's leave that till after the end of the lecture. We'll come back and we can talk about that. I have talked before. Sorry, there appears to be a whole lot of traffic noise. I'm going to shut the window. I feel like the mid-morning lecture I can get away with having a window open in this room. I'm trying to not just like turn this into like Mark sweats on stream, you know, like, but I think that it's better not to have background noise. Okay, so let's continue on with the lecture. And if you have any other questions, you want to talk about all these details and stuff, stick around afterwards. We can have a chat after the lecture. So, more stuff that we might do with Linux. Some of the things that you're used to doing in your computers. I'm just gonna set myself up here, is manipulating files, so copying files, moving them around and stuff like that. We can do that stuff in the terminal just as easily as we can do it in a GUI file manager. So if we want to copy a file from one location to another, we can copy, and then we write down the name of the file we want to copy and the destination of where we want to put it. If we want to move something, so we don't create a second version of it, we move it from somewhere to the other, we write down where it's coming from and where it's going to. The funny thing about move is you can actually use it to rename a file as well. So if you're going to move it from one source to a destination, you can say move it from this file name to another file name, and it will actually change the name of the file. So mv, the move command's actually got a double use because you can rename stuff as well. rm is sorry, I don't think the K-pop stands out there, but like every time I see RM, I'm just like, BTS. Anyway, so the to remove a file name, this is to delete the file. We type in the command rm and it removes it. So just be careful with this, because there isn't necessarily a like a recycle bin or anything like that. So if you remove something, it can disappear. When we're doing stuff like copying, if we're trying to go through and copy a whole... I knew the BTS thing was going to get some reaction there. If we're kind of trying to move a whole directory or copy a whole directory, you can't do it with the standard CP command. You have to be able to say, I would like to do this recursively. Recursively means go through and do all the files inside other folders and stuff like that. So we do that with the -r command. So I suggest that's a good way of moving, copying or moving an entire directory. Be really careful doing it with a file name. So if you do rm -r with a directory, it is going to delete everything in that directory. So you want to be careful that you would actually try to do that. So I would nearly say don't do rm-r in general. Go through and be sure of what things you're deleting if you're going to do that. Okay, maybe I'll show you some of that if I'm going to organize my files in the folder that I'm working in, but I think I've set up some of that stuff already. So let's go on to, I'm going to move my face over here for the moment. We're going to let our computer make decisions. So first meme of this lecture here. We're going to use this thing called the if statement in C. So one of the interesting things about our code, I said, with what's in our main function, it's all just line by line, and everything is going to get run one line after the other. Now we're adding something that says we're actually letting our computer make the decisions itself. So it is able to say, I am maybe going to run some code, but maybe I'm not going to run that code. And that's going to be this thing called the if statement that says, we're basically going to do this thing it's like a question and answer. I think I've got another slide on it here. So the question and answer in the if statement says, we ask a question, and this is us saying to the computer, can you check something? Can you look and see whether something is true or something exists or something like that? And if it does, then run whatever is inside the curly brackets of this if. So this has this particular layout where we use the keyword first. The keyword is if, and then we use the normal brackets there, and inside that is the question. I called it an expression here because it's a particular kind of code construct that we would call an expression. And the expression will always end up with a number. So that's the interesting thing about this, is C is based really, really heavily in numbers and in this kind of binary numbering system. So basically, what it will do is it'll say, if this expression, if after you've done all the maths in this expression, it's equal to 0, then whatever's inside the if statement, so these code statements, whatever they happen to be, this is not real code here, this is just example code. Whatever's in here will not run if this was 0, but if it was anything other than 0, usually we just use zeros and ones, but you can use numerical values, so it could be like 5, it could be 20 or something. If it's a number other than 0 there, then whatever is inside the curly brackets of the if statement will run. This is the first time also that I've shown you the idea of indentation. Like, I was just doing it on Wednesday. But what we will also do is inside the curly brackets of the if statement, everything is 4 spaces in here. And that just makes it easier for us as humans to read it. So we push it further in so that we can understand it. But the machine... I keep clicking on stuff. The compiler is actually going to be reading the brackets, but us as humans are going to be reading the indentation to know what's inside what. I think someone was asking that. Is it actually necessary to do the indenting? Because C could actually... Technically, we could put all this stuff on one line in C. It would just be like a massive struggle to actually go back through it and understand what was going on or fix things if we did that. So we space things out for our benefit. There's another thing that we can add to the if statement, which is the else statement. So this way we can have 2 paths, and we can say, if the question and answer thing came up true, then we go down one path. If it came up false, we go down the other path. But the if-else setup means that only one of these will ever run. So we either do the if or we do the else, but we always only do one or the other. So this is done in this layout. So again, keywords, if and else will be used. The if is first with the question. Then it has its curly brackets. And after its curly brackets finish, we can put an else, and it has its curly brackets. And so in here in the comments, I've explained, if this expression comes to something other than 0, which we think of as true, then what's here between these curly brackets will run line by line, same way that we run other piece of code line by line. If it was false, then whatever is in the else statement here will run. But if it was true, the else statement will be skipped over and ignored. So the if-else statements, like when we're going line by line through our code, the if-else statements allow us to switch on and off parts of our program. We can chain these together. I'm just going to keep moving my face around to dodge the code. We can chain these together in these collections of if-else statements. So I can say if something, but if not that thing, then what about this other question? So I could say something like, if the number's above a certain value, actually no, I'm going to talk about the questions later. So if this question is true, then I run this. But if it was false, let's ask another question. So if the first one was false, but the second one was true, then we run what's in here. If both those questions are false, then we'd run what's in here. You can put massive chains of these things in. I mean, they can get, well, like, as long as they don't get to the point where humans can't understand them anymore, like we do want to write our code so that we get it and we have an idea what's going on in it. But there's no theoretical limit to how much of these can be chained together. So you can have a whole series of different conditions. You can nearly do an entire kind of like, if you want to make a self-driving car, you could be like, if you see something, then stop. But if you see this other thing, also stop. If you see this thing, you can keep going. If you see this, then you have to keep your speed limit below a certain thing. And all this, you could just do it on a whole series of these. I don't know how well that would work, because every time your car saw something, you would have to go through all of this code to do stuff. But technically, that's the kind of thing that's possible. So, I'm going to move my face out of the way. Now that we know we have a system for turning on and off code based on questions that we can ask and answer, now we need to know how to ask those questions. So that expression that we're going in there, that was see if something is true or false, we need to know what kind of things we can do to ask the right question, in a sense. So these are what we call relational operators. Relational operators are things that always take a thing on either side. So you can give them two numbers, you can give them two variables, you can give them a variable and a number, you can give them a constant and a number, many different options like that. And these are things that you've probably seen in maths. And the only things you need to think about are how we're going to type them in C. So greater than or equal to, less than or equal to have a particular format in this. So these less thans or greater thans, I'm going to assume that you have an idea about how they work with numbers already. They're going to work pretty much the same way with variables or with numbers that you just type into your code. The one that tricks people a lot of the time is equals. So we've seen a single equals. This is a double equals. So one thing to get into your memories when you're programming is that the single equals and the double equals are very different things. So the single equals is what we call an assignment, different from the big assignments you're going to do, but this assigns a value to a variable. So it's an operation, it's a task that we ask the computer to do. The double equals is a question. So it's not a command to change the value of a variable. Instead, it's asking about two values and saying, are they the same? So double equals is asking a question, single equals is issuing a command. So it's just awkward. Like, I kind of wish that the single equals was a different symbol and then this double equals was just the equals. But unfortunately, this is the way that C is set up. It's just one of these kind of inconsistencies between it and mathematics that you need to sort of just get a handle on. This is going to come up again in different ways in every programming language, where there's things that you need to learn in order to be able to speak the language. In the same way that any human language you learn how to speak has a grammar, a set of rules for how it's used. and they all have something that breaks the rules of their own grammar. So this is the same kind of thing where we've got mathematics, which we're kind of relying on, but we've got this thing that's not quite the same as maths. So that's something to remember with the equals. We also have not equals to, which says, are these two values, are they different? In which case that's true. So all of these things, if you put a number on either side of them, when they run, they will say that they are 0 or 1. So this will take numbers on either side, and as it runs the program, it will say, okay, given these numbers on either side of me, I'm either a 1 or a 0. And that's the thing that will be fed into the if statement that decides whether or not you run the code. We can chain these together in interesting ways using these things called logical operators. The logical operators work on the idea that, the relational operators were figuring out the difference or the sameness or whatever between two numbers. These are the difference or sameness between logical values or the outputs of those other things. So we can chain two questions together. So we can say, is this number greater than this number? And is it equal to this other number? And we can have this and. So the double ampersand here for and will give you a true if both sides are true. And any other thing, it will give you false. So it has to say both of these must be true. So this and this are true, then I am true. This double bars, I think they're called bars. It's sort of like, I love it when there's keys on the keyboard that you don't really even know the names of. I think they're bars. Is the or that says, okay, you can have this statement or this statement. If either one of them is true, then I consider this whole thing to be true. And there's another one that we use to flip it. So if we put the exclamation mark in front of any logical thing, so anything that equates to a 1 or a 0, it'll flip it between the 1 and 0. So lots and lots of stuff. Jack's saying they're pipes, vertical bars, pipes. I call them bars, but like that's pretty funny that like I use this all the time, but I just forget what they're called, because when you're typing in, you don't say the name of the keys, so it's easy to forget. Yeah. So people call them pipes. Anyway, these things can be used to shape questions. So we can use lots and lots of different combinations of questions, and I think it's good to look at some examples here. I'll just cut off the top of my head for a second there. These are the way that these expressions could be put together and the kind of result that we would get. So if I put these in the bracket of an if statement, this one would run, but this one wouldn't run, right? So what I'm saying is 5 is less than 10. That's something that we can understand, and that will equate to true, which means whatever was in the if statement would run. If I put 8 not equal to 8 in an if statement, then the body of the if statement won't run. If there was an else, that would run instead. And these can get more and more complicated. So we can get down to this one, which just chains all of these kinds of things together. So 5 is less than 10 is true, or 6 is greater than 13 is false, because one of these on either side was true, and this is an or statement. It means that this whole thing is equal to 1. But then I've got the exclamation mark that's going to flip it, so it becomes 0. So all of those basic rules can just get bigger and bigger and bigger. And like everything else we're doing with programming, is there's no limit to how many of these we could chain together with these ands and ors and nots and stuff like that. It's just the warning that I would offer is like, try not to destroy human brains with your code. Because if you're destroying human brains with your code, then your code is only of limited use. Like, it'll only be useful once. And if someone needs to change something but they don't understand it, then they don't really know how they're going to change it to make it work. There was a question in there about can we do something like 10 is less than x is less than 15? That doesn't work. So each of these symbols wants exactly one thing on either side, and you can put brackets there to ask another question there, but you can't just do a variable in between two numbers. It's got to be two separate questions. That's just like a C syntax thing that's going to ask you to do that. Okay, so let's get into a coding example. We've got half an hour left to do this, which is good. Anyone here play Dungeons and Dragons or other role-playing games? This is not Dungeons and Dragons, by the way. It's not even how Dungeons and Dragons works. I just wanted to reference the idea that we might use dice, and also we might use programs to help us work with dice. So I think there's plenty of people nowadays who, like, in social distancing worlds, we can't play our RPGs and our board games and stuff that much with people around us. I mean, we kind of can, but it's limited, you know. So I play board games with a select group of friends, and we don't mingle with the public when we're doing that, because it's a little bit like we just don't necessarily want to do that. So here is a program that I've come up with. Someone said 40k Dark Arrows. Anyway, sorry. Not going to be biased towards certain people because they play the same games as me. Okay, so this will help in our games of Catacombs and Large Reptiles, which is my way of dodging saying Dungeons and Dragons, but I'm happy to say it's alright. So, we want to write a program that helps people work with dice. So, we have something where we can roll 2 dice, and we tell the program the results of the dice that we've rolled, and the program will then check them against target number, and maybe the program knows the target number, but the humans don't know the target number. And so what we can do is we can get the program to tell us whether or not we were successful. Hang on, I'm just going to grab a set of dice. I've usually got some lying around. I've got a box of dice here, so just in case we need to use them, I'm just going to put them down on the desk next to me. I should have a separate camera just for the dice. Like, I think people who stream games, board games, have that. So, these are the things that I need to do for the program. Program must be able to receive input from the user and tell the user stuff. It must be able to check against a target number and report back whether we're higher than equal or lower. So I think what we're going to do is just higher or equal or lower. We're going to separate into success or failure. So if we've met the target number or not. Oh, I'm on the wrong slide. So, what are the ingredients we need? And do we have these ingredients available in what I've taught you so far about programming? So we need to be able to tell the user things and get information from the user, which we can do with printf and scanf. So we know we can put stuff on the screen, and now we know we can actually take stuff from what the user types in. We need a way to compare numbers. So we need a way to be able to say, are the numbers that were typed in, are they higher or lower than the target number? So we're going to use our relational operators to do that. We're going to be testing those numbers against a secret number. And if we think that secret number is not going to change while we're running things, then we might use a constant for that. I will probably use a constant because I have put together this example specifically to try to show you different programming constructs. So it's good that if I show you a constant. We do want to tell people whether or not they have passed or failed this particular role. So if we've passed or failed that particular role, then we need if-else statements to decide which bit of code we're going to run. So you can see here, this example's obviously been put together to chain together everything that I've talked about today in terms of code. We're also going to need variables, which I haven't even put in here, because we're going to need to be able to store numbers in variables. So if we receive the input, we need variables. So basically, this demo is everything that I've said today, including, I guess, some of the stuff that we talked about on Wednesday as well, piece that all together into something. So, first thing I'm going to do, I'm probably going to say some information about it. I have a whole bunch of stuff in the slides here, which is potential code that you could use for this, but what I'm going to do instead is I'm going to do it all live, because I think it's much more interesting if you see me type it all in, rather than me like sort of copy pasting stuff from the slides like that. So we're going to hop in here now. I'm going to click on the terminal emulator here to open up my terminal. Where am I at the moment? Okay, so the folder that has the code that you can load, so if you're on the web page where you can load my code, I get to it from my end via this thing called public HTML, which is the thing that just publishes my little web page there. So I go to cd, public HTML, and it changes me to that directory, cd, change directory. I can do an ls to see what's in here. I've got lecture 1 and lecture 2. I think lecture 1's not visible yet, so lecture 2 is visible if you go to that link. So I can change directory to lecture 2. And in here, I have this test.c. Don't worry about that one. That's just a backup. But I have the test.c, which you can look at there, which was just my thing to make sure this was working when I was testing it earlier today when I set it up. Someone's asking if there's a super chat. I don't think there's I don't have any of the kind of like full-on monetization or anything and stuff in there. Okay. So now I don't have a code file for what I'm making today, so I'm going to make one. And I'm going to do that by letting the gedit application... Oh, you know what I'm going to do? I'm going to shrink my prompt by going cd tilde, which goes to my home directory. And then I can go public HTML / lecture. Oh, let me show you something cool, because I haven't shown you this yet. If you press tab when you're typing things in the console, in the terminal like this, it will try to autocomplete things. So if I say pub and I press tab, so I just press the tab key, it's on the left of your keyboard there, it said there's only one thing in all of these directories that starts with pub. So it's going to be public HTML, which is nice. And then if I want to go to one of these two lecture directories, I type in lec, and I'm going to press tab, and it's auto-completed as far as it can. So it hits this point where there could be a 1 or a 2, so it stops there and says, I don't know which one it is. And so I can do 2 here, and this can speed up my process. So if I'm tab completing things, it's a little bit faster typing things in than if I type every letter in one at a time. Okay, so now I'm in lecture 2. ls shows me that I don't have a code file for today in here, so I'm going to use gedit to create it. What should I call it? I'm going to call it dicechecker.c. And remember, the command I was using was and, which would allow this terminal window to remain active while my gedit window is active. I'm going to shrink this one down a little, dodge my face. Actually, maybe I'll just put it here. Yep. Okay, so now I've got a window to write some code. Let me start writing this. Is this big enough? So, dice checker lecture demo. I feel like that text isn't big enough. I'm going to increase the size. I think I had 28 over there, so if I go to the same thing, that should work. I think all of my settings are when I was doing this on a smaller monitor. So between last year and this year, I bought a very fancy 1440p monitor, so I need to make everything a little bit larger so you can see it. Okay, so dice checker lecture demo. This program will take input from the user about what numbers they rolled on 2 dice. It will total those. I'm gonna say more explicit. It will add those values together and see if the total reaches a secret target number. Then we'll report the result to the user. Up to you what level of detail you want to put in here, but especially for something where I'm demoing pretty much, the second program that a lot of people will ever have seen, I want to make sure that there's full understanding here of what's going on. And I will usually sign off that I have created this some way to contact me. And what are we? We are still in February 2021. Okay, basic setup that we're going to have. We're nearly always going to be including, I need to spell it correctly, the standard input-output library. And for our program to run, it needs a main function. So I'm going to need my int main void. So there's a lot of stuff that I won't remember off by heart, but some of this stuff I remember off by heart because I've just typed it in so many times. I probably should have this somewhere where I can just copy paste it into every program that I create. But anyway, here's our starting point. So our starting point here says this is actually a fully functional program. It does nothing because there is not even a single instruction inside the main. Or maybe I'll put one instruction in here. By the way, I'm also using tab in gedit here to indent. In gedit, it's not all editors, but in gedit, every time you press tab, it puts 4 spaces in there. So there's a difference between a tab and a space. The spaces are more consistent when you're opening the file on different operating systems and stuff. So what I like is part of our 1511 setup makes sure that this, every time I press tab, it goes 4 spaces in. Also, you're going to see these a lot of the time when gedit is running. Don't worry about that. There's a whole lot of little warnings in here, but the warnings in here are actually to do with gedit's autocomplete here. So if I start typing words that I've typed before, so I think if I type in secret, it starts looking up words that it's seen previously that I've typed in. Sometimes it can't find things and little warnings will pop up there. They're not a problem. They're not gedit crashing. They're not problems with it, but you are going to see these things come up every now and then. So don't worry too much about them. Okay. So I'm going to take input from the user and I'm going to store that in 2 number variables. And because we're looking at dice, these are some of my dice here. Dice don't have decimal values. They don't have fractions on them. Well, at least my dice don't. I'm just using really basic normal dice here. So because they don't have that, we're going to use integers to store these. So I can set up 2 integers here. Die 1 and die 2. I kind of didn't need to set them up right then at the beginning, but it's sort of okay for me to do that. Then I'm going to ask the user for the first die value. Oops. See, the autocomplete there tried to put values because I typed in values earlier. So if I want to ask the user for the first die value, I need to say something to the user. I have a method for talking to the user here in the terminal, in the console, and that is printf. So you're gonna get this feeling for how I code a lot of the time, and so you'll see that what I like to do is complete things before I fill them out, and also I will often write the comment for what I'm intending to do before I do it. That way, when I'm just looking at my code, if I zone out for a moment, because it sure is 5:40 on a Friday afternoon and I'm still coding. So if I zone out at any moment, it's not too bad because I can look at it and say, oh no, I had a plan for what I was doing here, so I'll follow that plan. So I like to write the comments before the code. So in this printf, I can ask the user to do something. So if I'm going to be really polite, I'm going to say, please type in the value of the first die. And there's a choice to be made here whether I do a new line, and if I do a new line, then they will type in the number below, or if I don't put a new line, then the user will type in the number just after this text. So we're going to do it, I think, like this, and then we'll type in the number just afterwards. And so if I've prompted the user to type in a number, what I might then do is oh, people are asking questions. Okay, I'm just going to assume Jack's got the questions covered for the moment. Okay, so if I've asked them to type something in, then they have the expectation they're about to type something in. So I need my program to accept the input. So I'm going to do scanf, and I'm going to say I'm expecting a integer input, and it's going to go into die 1. Now, remember, there was that fiddly thing with scanf, which I'm going to tell you all about in a few weeks' time, but it's super complicated, so for the moment, we're just going to remember it instead. We use the and we're going to go into this variable. So if I want to, I can actually autocomplete here and just press enter, and it'll be like, that will be exactly the same way that I typed in that variable earlier. So now, what I'm trusting to have happened here is that this has said something to the user, and then this has accepted a number input from the user. And for the moment, we don't really have time to go into the full-on details of this, but I'm sure people are going to ask, is that this will only take a number input. If the user gives us an input other than a number, there are going to be problems. But for the moment, we're not going to worry about those problems. In terms of having these big problems and fixing them, we'll go into that in more detail later. For the moment, I'm just going to assume that our user is going to give us the correct input. So this will give us the value of the first die, and it will store it in the variable. What we might then do is repeat this for the second die. I realize I probably could have copy-pasted that whole section, but I'll type it in again anyway. So, if I want the value of the second die, I will do a printf, which is requesting the value of the second die from the user. So for the moment, I'm keeping this really simple and just doing 2 dice. I could do this with like big combinations of multiple dice and stuff like that, but things would get more fiddly the more we try to do things. And for the moment, I want to show you the concepts and how they work. So in order, these things happen. First thing, we assign memory for these two, so we know that we can store the numbers. Then this appears here and asks the user to do something. Program freezes on this line until the user types in the number. When they type in the number, it goes in here and it gets stored in this memory location for where die 1 is, and then another line will get printed out. So we're going line by line, just as we were doing before. Another line gets printed out, and then after that gets printed out, we will scanf to store another variable. So again, it's a decimal integer, so it gets the D, but this time we're going to store it in the other variable that we created, which is die2. So having done this, we should now have the numbers that were typed in stored in these variables. And at this point, I've written enough code that it could be worth checking that this stuff is working. So let's do something to check whether this is working. We're going to do a printf that outputs the number values. Also, let me Control S. So I've just saved this. So if you're looking in the website directory where I've got it, you've got exactly what I've got now. So every time I save it, you can just reload it and you can see that code if you need. It's not going to look pretty like this though, because you'd have to download it and throw it in a code editor for the nice syntax highlighting to appear. Okay, show the values of the variables. I'm being very, very verbose with my comments here, so verbose means I'm saying a lot, just to make sure that when you look back at this later, you know what each of my lines of code is doing. Value, let's call them die1 is something, die2 is something, and I might put a new line on the end of that so it's just there on its own line. The interesting thing about, there's no new lines in any of this stuff. The reason that there's no new lines in any of this stuff is each time the user types in a number, they're going to press enter for us. So we're relying on the user to actually put the new line at the end of this sequence of input and output. I'll show you that when it runs. So die1 is this, die2 is that. This should then give us the results we want. So let's test this, because we've written enough code now that we should probably test this. So Control S to save this. So I'm using keyboard shortcuts to save. You don't have to use keyboard shortcuts. If you want to click things, you can click on this button here to save things. Okay, so when these warnings come up, it can make the console here and the command line a bit confused. So what I will do is use this command called clear, and then it will just get rid of everything that's there before. My pop-up, oh no, it's fine. My pop-up had just popped through there by accident. Okay, so if I do an ls, I can see my files in here. The dicechecker.c is the file I'm interested in. So let's bake the cake. DCC is the thing that's going to take this recipe in the C file and turn it into a program that the computer can run. So I say DCC, and I'm going to tab complete dice checker like this. Makes it easier. I don't have to type it all in. And the -O is going to say output. So this is what I want to name my cake that comes out the other end of this process. I might actually just give it the same name. The difference is the .c file is the recipe, and the thing without the .c file is the thing that can run. Ooh. Oh, did anyone catch that? Did anyone catch that? Were people saying the was Mark putting the variables in? I'm not sure. Not sure if anyone. Some people must have noticed that, right? So, because we talked about this earlier, I didn't actually put the number variables in, so I was just like, oh, I'm just trying to print out these numbers, but I haven't said which ones I want. So die 1 and die 2. So the first one matches the first one, second one matches the second one. Now this should work. I think this is really great. This is great to see that, like, it doesn't matter how much experience you have, mistakes are going to happen. So this warning told me there were more % conversions than data arguments. So keywords for everything, but you can tell what was happening. The % things here were expecting information afterwards, and there weren't enough. So let's try that again. Oh, did I save that? Yes, I saved that. I should show you also what I did. Do you see how that command just magically appeared? That's another trick of the terminal. I used the up and down arrow keys to go through my previous commands. So I knew that that was the compilation command that I'd done previously. I wanted to run it again. So I pressed the up arrow, and the up arrow goes back, and you can go back through all of your previous commands, see all the commands I had before, so you don't have to type them in again. So often when we're working on code, this combination where we're going to compile and then we're going to run something is going to happen over and over again. So I'm probably going to be using the up and down arrow keys heaps just to redo the same things. So I press the up arrow key to do this compilation command. Since I have not typed in the run command that actually uses the thing that I've just baked, I'm going to call it baking instead of compiling from now on. I will have to type this one in the first time, but at least I can tab complete the name of it because I know that the file exists there. So let's run this and see it working. So please type in the value of the first die. So we know that we've gotten up to here in the code, and now we're here. So 2 dice here, I'm going to roll them. I don't know if you'll be able to hear it. They're both the same number. I don't want that. I'm going to do it differently. I've dropped one off the table. I'm doing well here with the dice. Okay. So I rolled a 6 and a 2 on these 2 dice. It took me longer than I expected, but okay. So let's say I rolled a 6 and a 2. So I have the 6, and I press enter. So now it's saying please type in the value of the second die, and that's a 2. So I'm going to type in 2, press enter, and it's going to say die 1 is 6, die 2 is 2. Good. So we know now that the first number I typed in got stored in the variable die 1. Second number I typed in got stored in the variable die 2. This is good. This is what we want to have happening. This means that this code here is doing what we want it to do. It's interacting with the user probably correctly. I'm never going to say it's 100% correct. I'm going to say it's probably correct because I've only tested it on one example, but I think it's working. So I think that the user's values are going into these 2 variables. So what I was supposed to be doing was checking this against a secret number. So if I want a secret number, I'm going to use a constant for this. So let me go back to, where were my constants? Here. If I'm going to do a constant, I'm going to use a hash define, and I'm going to use some all caps. So let's do that here, and let's say hash define. So define says something is going to be something. All caps, so that we know it's something that can't change. I'm going to call it secret target. It's really, really clear what that means. And let's just make it a reasonable target for something for rolling 2 standard dice. So we call them D6s, which is 6-sided dice. A simple target for them is a 7, because that's the average value for those 2 dice. I just know that because I played lots of games with dice. So if I have the secret target 7, then I want to check whether something has reached that target. So the first thing I might do is say add the values together and store them in a total. So if I'm going to store them in another variable, then I'm going to make another variable and I'm going to call it total. And instead of here where I didn't give these things values, so there's actually interesting stuff going on here, that there are no number values in these variables. So no numbers here, they become numbers when we read the number using scanf. So we read the number like 6 here, and only then does die1 get its first value. So instead of initializing with like something equals, using the equals initializer, we're actually using scanf to give this thing its first value. If we go deeper into this, there are potential issues with that. But for now, we're just gonna work as if everything is working fine with no problems. Because if this scanf didn't work properly, then this never had a value, and there's all these issues later. But we'll talk about that in later lectures. So my total here is going to be an integer, and that integer is going to be a combination of these two dice. So we're just going to add up their values. So die1 plus die2. We add these two together, they go into the total. In this example here, we would have gotten a total of 8. We also might want to check this, and not even just check this. This might be something that's nice for our user to see. Total value is, we'll do a %d, and we're going to do a new line on the end of this so it goes down on its own line. And the value we want to put in is this variable, total. So we need a variable to match up with the % symbol there. Total. All right, so now when we run this, we should see our total. But the next thing that we want to do is check if we've check if the total is equal or higher than the secret target. We're going over to the right a little bit here, but I think it's okay. I think we're still going to be able to read it. So if we're checking if something is higher than something else, I mean, I've used the keyword already, if, which is going to be the question there. So checking if this total is equal or higher than the secret target, we're going to ask the question in an if statement. So if statement has a question, and you can nearly think of the curly brackets here as being the answer to the if statement. So I'm asking if total is equal or higher than secret target. This is pretty good because I have a variable named total and a variable named secret target. So this is something, it's never going to be clearer than this. So total is greater than or equal to, if you need to go back and check the kinds of questions we can ask, they're here, and I can see that greater than or equal to is used with these symbols in this particular layout because we don't have a greater than or equals to key on our keyboard. Okay, so if total is greater than or equals to secret target, then I know that we have got a success here. So sometimes I like to, in the if statements, leave comments for myself that says this is what this one means. So if it's a success, I need to let the user know that it was successful, and I can say dice, need to spell, dice check succeeded, and have an exclamation mark for your success. Now, at the moment, we're thinking that any value that did not equal or get higher than the secret target is not a success, it's a failure. So what we can do is, instead of having to ask a question that says if it is lower than the secret target, I can just say else. And I can say this is total less than secret target. I don't need this code to run because the else is actually doing the same thing as the total less than the secret target. But what I can do is I can just leave this in here as a comment to someone who's looking at this code, and they can be like, oh, if we're in the else, this is the programmer saying, okay, this is how we got here. We got here because this thing failed, which means this must be true. because it's the only other option in this kind of set of numbers. So if the total is less than the secret target, then we consider it a failure. So we would print out dice check failed. And you're not going to get any exclamation mark if you failed. All right, I'm going to save this because I'm really running out of time at this point. So I'm going to run this now, and we'll run it, and we'll see this going through these instructions one step at a time and see it running. So using my up and down arrow keys, I can get my DCC command. It's weird because the warning is on my prompt here, but it's still going to type it in. I didn't get any information back when I ran DCC. So DCC, if it has nothing to tell us, it means it succeeded. So let's say that succeeded. I can use my up arrow to find my command to run the program. And okay, run dice checker. Please type in the value of the first die. I'm going to roll my 2 dice now. I keep rolling the same number on both dice, which is like a little boring, so I'm going to roll this again. I've got a 4 and a 3. So that's like nearly dead on average for these dice. So first die is a 4. Now please type in the value of the second die, and I said before, so I've got these values, a 4 and a 3. So second one was a 3. And it says to us, die 1 was 4, die 2 is 3. This was just some information we had so that we knew what was going on. Total value was 7, so we can confirm that the maths is working correctly. Dice check succeeded because we were, if we look at our secret target, here, the secret target was 7, we matched the secret target. Let's run this again, and I will, if I don't roll low enough, I'll doctor the dice so you can see the other result. No, that's too high. I'll re-roll one of them. Okay, I got a 3 and a 1 this time. So I'll type in a 3, type in a 1. Die 1 is 3, die 2 is 1, total value is 4, dice check failed. So, going back to my slides. Sorry, I'm a tiny bit over time. So, we have a dice check program. If you need the code as I was writing it was going up here. Don't worry about any of the files in there that aren't C files. They're not necessary. You can just use the C file, and then you can play around with it. So I have some challenges for people. These don't actually have achievements attached to them, although maybe I should. I don't want to throw like a million achievements into this course, but if you're interested, this could be something to look at. There are other things that we could do with this code, and using what I've taught you so far, some of these things are actually not that hard to do. So, could we detect exact ties as well as success and failure? So, could we detect a situation where we hit the target precisely, and then we have a success which is higher, something that's equal, and something that's lower? Can you chain the if and else statements together to do that? I think you probably can. Could we have the idea of a critical? So if we roll, as I did several times today, roll the same number on both dice, could that be considered a critical in the game that we're doing? And could we report critical success, critical tie, or critical failure as well? So can you now play around with what I've shown you and do other things with it? And then for people who want to go really deep, this involves stuff that I haven't taught you yet. What about randomization? What about we don't roll the dice as humans? What about the computer rolling the dice? See if anyone's interested in doing that. That is like way beyond what's necessary at this point because it involves stuff that I haven't taught you. But I thought, interesting question anyway. So we're going to wrap it up there. Thanks all for coming along. What we have learnt today is we've learnt about variables. So we've learned about storing information in memory and a lot of the fiddly bits that make up variables, bits and bytes, types of variables, some of the ramifications of using them, and we've also learnt about if and else statements and the kinds of questions that go into them, relational operators and logical operators. The example we did today, reasonably simple. It only had, I mean, I say it's simple, but like if this is the first program you've ever seen, it's not simple at all. But we had output statements, input statements, and a doubling up of that, and more output statements, and then we had using variables and initializing them using other variables, and then testing if and using if and else. So all the stuff I've taught you today is kind of in this program, but there's going to be way more detail than that in your tutes and labs, so you can get more practice with this and get a good understanding of it next week in your tutes and labs. So thank you all. I will see all of you Wednesday morning. If anyone has any questions, they want to stick around, ask questions, I'll go break time, grab a bit of water, and then come back and answer your questions for a little bit. This is the same as like when we were doing this in person. I used to hang around outside the lecture theatre and people can come and ask questions and stuff. So I'm doing the same thing but virtually. So I will wrap up the official thing now. Apologies for going over time at this point. But the official lecture's over here. But if you have questions, stick around, I'll answer them afterwards. Oh, there's requests for chicken. She's actually just still sitting in the same spot there, but she's sort of moved to another part of that little chair there. She has complete disdain for you. She's just looking away. All right. See you soon. Alrighty, we're back. Let's see if she wants to say hi. Did you hear that? Do you want to say hi to everyone? She meowed when I picked her up, but then she's chill now. She's gonna be like, oh, I got a lap to sit on. This is nice. Okay. Did anyone have any questions? Did you want me to clarify anything in the code or anything like that? I'm also totally fine if everyone is just like, nah, dude, it's Friday afternoon. I wanna go and just kind of zone out now. But if anyone has any questions or clarification and stuff like that, definitely here to help with that. Hussein's asking, do we upload the challenges somewhere, or are they just for us to practice on our own? Just practice on your own. You don't have to. If you want to do the challenges here, just do them for the fun of it. It's just about learning and practicing. It's not necessarily about handing them in. You do get bonus marks. I love this joke. They're marks spelt with a C. They have no value in the course, and they don't actually exist. But you can call yourself getting bonus marks for doing challenges. Oh, Josh is asking about deleting the file with the tilde. Up to you. They are a previous copy of the file you have in case you accidentally delete it. If it gets annoying in terms of like just these extra files that you don't want to see in your directory because you're trying to organize things, then feel free to delete them. Just know that they're also kind of there as a little bit of a in case you stuff up, they're available. So if you stuff up and delete something by accident, you can look for the tilde file and have it there. So up to you. I leave them there because, you know, if I delete a file mid-lecture, that would be really disastrous. So I make sure that I've got those backups there. But up to you. If you're really sure of how you're handling your files, you may not need them. Feyue is asking, I don't know if I pronounced that properly, sorry. You can't find anything in public HTML. If you're looking in public HTML on your account, it will be empty. But this is my account, which is different from your account. If you want to access my files, you access them via this link. So my public HTML gets published as this web page. Your public HTML actually gets published as a web page that you can have with your ZID there, but you won't have anything in your public HTML for the moment. If you want to access the code's available at this link. Oh, as Sherry's saying, some challenge exercises do have marks and they're submitted. So anything that's a challenge in the lab does actually have marks attached to it and stuff. Kaushik's asking about reflections. Reflections also have marks attached to them. They will be marked by your tutors in the labs themselves when they have conversations with you. George? Sounds like George was answering someone else's question about variables and constants. That variables can change, constants will not change. Constants are set in stone for the duration of the program running. Eleanor's asking about the and before the variable. Let's go back to the code. So, the details of the and are that when you put a variable in something, so like this, in the printf we put the variable in, what actually happens when this thing runs? So let's say I put a 6 in here and a 2 in here, that first example that I had. This ends up looking like this. That becomes this kind of 6 and a 2. I'm going to undo this because I don't want the code to end up like that. But the 6 then goes in here and the 2 then goes in here because that's how we have talked about those variables. If we do this here, and this doesn't even have a value yet, but let's say this had a value to begin with. It's kind of meaningless because we're about to override it with a scanf. What would happen if I didn't have this and? So if I had it with just die2, what this would do is as the program's running, it would go die2 is 4. And scanf would be like, I can't put something into the number 4. That's not how that works. So what the and is actually doing is saying, I'm not looking at die2 as the value 4. The and is saying, I want to get access to this. I want to get access to the actual integer stored somewhere in memory. And the and is the way of us saying, I don't care what's in there at the moment. I want to know where it is so I can write something into that location, in a sense. We're going to go into way more detail about how the and works later and how you can actually use it. But for now, you can think of it as that distinction. So if we want to give the number value to something, we use the variable's name. But if we want to access the memory that the variable is in, then that's what the and is for. For the moment, though, like there's way more I'm going to teach you about that. For the moment, all you have to think about is scanf uses the and, printf does not use it. And scanf's the only place we're going to use the and up until I start teaching you about exactly the proper kind of subtlety of how it works. Okay. Kazi Hassan says, how do we put a restriction on the numbers users can input for the variable? Well, that's next week. I actually have stuff in next week's lecture which is entirely about, okay, this week we did this thing, but what happens if there's different kinds of input, and how do we solve those kinds of problems and ideas about what's going on? So we're going to have a whole lecture on that, which we will start to kind of verify the input and see how it works. So I apologize, I'm not answering your question, but I will answer it in great detail next week. Ayub is saying, is it possible to code for randomization with what we've learned so far, or will it require Googling? It is not possible to code for randomization with what we've got so far. At the moment, everything that I've coded is very lockstep. This happens, then this happens, then this happens. There's no way for us to put in a number that the computer comes up with. Everything is something that we've decided on. Fanchen's asking, I want to know where to find the challenge task. This was a very informal challenge. This was me just saying, hey, these are some things that you could do if you want to. So there is nothing else in this task other than me saying, this is something interesting. You can take this code and modify it and see what you can do with it. So those challenges are entirely optional, and you don't even have to do exactly what I'm doing here. You could think up other ways of doing things. If you're someone that does play Dungeons and Dragons, you'll note that this idea of rolling 2d6 and seeing if it's higher than a number is not even the way that the system in Dungeons and Dragons works. You could rewrite this code to be a genuine Dungeons and Dragons skill check instead, where they use 20-sided dice instead of 6-sided dice. So lots of cool things you can do, knowing that what we've written here is not set in stone and is always modifiable, and you can do other things with it. Hussein is asking if VLab has a memory limit of 8 gig. Does it also have a storage limit? It does. Your account has a storage limit. I can't remember. I'm gonna guess the command. I think it's rquota. Yeah, there you go. Rquota is something that tells you how much you've used, what your limit is, and also the number of files you have, how many of those. So at the moment, I have 2 gigabytes worth of storage with which to run COMP1511. I'm using 370 megabytes of it now. And that's in 14,000 files. So there's a lot of stuff in my in my directory. Yours is going to be obviously a lot smaller than this. Also, your quota will be less. So that's the limit that you can use. I don't know if there's a better command than rquota. This is something that I've just sort of memorized. Shrey might know a better way of looking this up, but I think it is. And George is saying, wasn't the challenge message of the day? So the challenge for the labs was message of the day. So you can always look at that if you want to. But this was just something where I said, look, this code is not the end of what we've learnt in this lecture. You can do more stuff with it if you want to. So here are some ideas of some cool things you can do. So it's not official, it's not marked. It's just something to say that if you want to see how much further you can take this idea of the dice checker, there's things that you can learn about. William's asking how many reflections we have in total. I think it's 4. It's either 3 or 4. We haven't 100% locked in the plan for the rest of the term. We're still figuring out where the best place for them are. This is the first time that we've done these reflections because we realized that people can get much better teaching from their tutors if we can get them writing information about how they're going. And so this is our first term trying it, so we haven't locked everything in 100% yet. Tuv is saying, can we use if-else after the if to try to make the secret target between 5 and 7? Yes, you can. So if you you do something like this, if-else, you put another question in these brackets here, and then you can do another else afterwards. Or if you have lots of questions to ask, you can do another if else, and then you have this thing where it's like, if this, no, what about if this, no, what about if this, and it will run exactly one of these chunks. Oh, sorry, I didn't close those brackets. Yeah, so you can do that kind of thing where you put more of these questions in. So definitely these things can chain, and if you want to, just gonna put that back the way it was. Yeah, so if you want to chain multiple questions, that kind of thing that I said before about the exact tie, or you want a region to succeed or not, you want an entire simulator for like dice games based on 2 dice, you can do that with this, with lots and more of these things if you want to. Fema said, thank you, you are welcome. I don't know how far back I am at the moment. I'm a little bit behind the questions at the moment. I should turn timestamps on so I can see that. Yeah, I'm like 10 minutes behind. Okay. William, it's not 1 reflection a week. It's less than that, I think. Oh, wait. Maybe it is 1 reflection a week. But they're going to be checked in batches because we don't have enough time to have the tutors have one-on-ones with everyone every lab. So I think it's going to be the kind of thing where like you'll do a reflection every week, and every 2 or 3 weeks your tutor will talk to you about the things that you've been writing in your reflections and help you out with any questions you've had in there and that kind of thing. I should check this because it's brand new, so I don't know everything off by heart. A lot of the other things we do in the course I know because we've done it multiple times, but I'll have to look really closely about exactly how. Because the funny thing about the reflections is we've made multiple different models of this, of how we were going to do it. So I could accidentally tell you information about one of the previous incarnations of how we were going to do it. So I should just say we will let you know how everything works as it goes along, rather than me trying to answer questions now and accidentally say something that's incorrect. Caleb saying can you submit the message of the day thing? I think you can. I don't know if the message of the day thing is something that gets submitted or something that you just get to do and gets used. There's no marks for the first tutorial lab because it's more of an orientation introduction thing. But the challenges as we go on during the term, you'll definitely be submitting them. Ryan, what's your favorite 40k faction? We are a little bit off topic here, but the two factions I play are Crimson Fists and Craftworld Eldar. They're from way back. I also have Death Guard. They're cool as well. But anyway, I'm going to move on quickly from that. People have real questions. James completed the first challenge. Congratulations. There's no upload for this one in particular. It's just that warm, fuzzy feeling you feel inside from having completed it. Hussein's asking about rough idea of size. I think that was talking about how much space you have to do stuff on CSE servers, so you can probably check it via that R quota thing. Shrey said to Eleanor that I would answer that. Have I already answered it? I'm going to scroll back up. Yes, I did answer that one, so hopefully that helps. Is print variable 1 plus variable 2 a valid code? Alex asked. Okay, cool question, right? So, if I didn't need this variable, I could actually do this. So if I didn't need that total down here to check against things, I could actually say that this just has to be a number. Right, so the thing that's going to be printed out, separated by commas if you go multiples, this just has to be a number. And the program, when it runs, is going to see anything as maths, and it's always going to just run all that maths and end up with a number. So if it does that and ends up with a number, this will be the same as total, which was the adding of those two together. So yes, you can put more than just a variable or a number value in there. You can put things that end up as numbers, and the program when it runs is going to be, this thing ends up as a number, so I'm going to crunch all the math and turn it into the final value of the maths that's there, and that's the thing that's going to get printed out. So yes, Alex, you can do that. Alan Chang is, if both equate to 1, what will happen? Oh, if we do an OR, which is the double bars, OR, and both equate to 1, that will be true because the OR is true if either of them is 1. So if both are, that still says that either of them is 1. Hussein has a question about VS Code and Xcode. I'm not actually too up on the setup and everything for that, so I'll let maybe Shrey or someone else answer that one. Ricardo, you just do well. Okay, we're not there yet. But yeah, we'll get to looping eventually. Steven said, silly question, but how do we complete achievements? No silly questions. But achievements all have codes that you type in. So you go to your student page of WebCMS, and there's places there where you can type in codes, and then achievements will be completed there. Some achievements will be completed automatically, depending on what they are. So we'll see how that goes. This the back-end code for this is Tom's baby. So if you ask on the forums, you will be able to get an answer there potentially from him about exactly how the achievement systems works. So I'm like oversight, but I let him write all the code for it. George saying, can we use if statements to restrict the input? We can do stuff like that. So we could do things where we read the input and then we do if statements on the variable after the inputs come in. Again, jumping ahead, we are actually going to talk about that in a future lecture when we get into more complicated use of this stuff. William said, thank you. I guess I must have answered your question before. You're welcome. I think that Shrey has also said, yeah, codes typing in, and there's some hidden codes around the place. Hussein was asking what is a critical success tie failure. I just made that up. So that was an idea of if you are... it was just another condition we could do, where if you roll 2 of the same number, can you write code that checks for 2 of the same number, but then still checks the total against success, tie, and failure, and can say some successes, ties, and failures are criticals and others are not criticals. So you could... that's just an example of something that you can do with this code to do more interesting stuff. So James saying you struggled with the if, else if, and else challenge and realized that else was just all of the other options left after the if and else if statements. Yeah, so else is just like... if this thing hasn't triggered, or if multiple things here haven't triggered, this thing always does. So the else is the all other possibilities at the end. So nearly every time that we have these ifs, if we have a long chain of ifs, there's nearly always going to be an else at the end that just says, all right, we will do some behavior if we haven't caught that behavior in one of the other conditions that we were checking. Fei is saying, can I transfer a document from VLab to my own computer? Wait, I've scrolled the wrong direction. And the answer to that is yes, there are ways to do that. I think that depending on the system you have, SSH might be the good way to do it. I think Shrey has given you a link there to do it. Hopefully that's what that is. Or maybe that was the link for the reflections. Oh, it's a taggy at CC. So I think Shrey's already answered that question, because it's actually hard for me to answer it. It's much easier for Shrey to show you the documentation for doing it. So you need to have some stuff set up on your own computer to be able to link to us and make that secure file transfer, basically. Misspelt is asking if lab challenges count towards your mark. Lab challenges only count towards your mark if you haven't got the maximum mark in the lab. So a lot of the time the challenge can kind of make up for if you've made some mistakes somewhere, or if you can't make a lab, if you're sick at some point and you don't get a chance to do it, some of your challenge marks can make up for missing that. Even with that, the lab marks are 1 less than the total number of labs that are assessed. So if you miss one lab entirely, or you have an accident or something and you can't go to one of the labs, you can still get full marks in the lab component. The challenges can get you up to the maximum if you've made some mistakes somewhere else in the lab. But otherwise, they won't count for marks if you've got full marks already. Blank is asking, is the message of the day challenge marked? It is not, because the first lab isn't marked. First lab's more orientation. We're not assessing you yet, because especially some people had their first lab before the first lecture, so it's kind of unfair to be assessed on something when you haven't been taught anything yet. Oh, someone was asking about new lines and stuff like that. Oh, that I think that got retracted, but someone answered it. Yeah. Sneha Besu is saying, do you have any other practice questions? I don't right now, but the labs and the tutorial labs next week will have plenty of practice questions, and then we will be releasing revision sets of questions the week after. So week 3 onwards, there'll be these revision questions that you can hand in the same way as you hand in the lab questions, and they will tell you how well you did on those things. So they're not marked, they're not worth any marks, but they're probably worth something in terms of revising things, and they're worth stuff for revising for the exam as well. So there aren't necessarily questions there, but yeah. Shrey, yeah, I apologize, because Shrey's keeping up with chat, and I'm reading chat like, I think I'm 10 minutes behind, so I'm probably answering things he's already answered. I wonder if there's a way to mark some questions as answered or not. But anyway, because we're using this chat, it's like this for the moment. Snare is asking, can we just use many ifs instead of if-elses? Yes, you can. But things get a little bit different when you do that. So, if I have this, if this happens. And then I add another if something else, something happens, and I add another if something. If I do this, all of these will be checked. If I do a else if with these, only one of them can run. So there's a subtle difference here where if I do this, and this is true, and this is true, all three of them will run. But if I do all of these as else ifs, this will only be checked if this failed. This will only be checked if this failed. So what that means is a sequence of failures must happen for anything to be reached with these elses. But if you do the ifs, you can succeed or fail in multiple of them, and run multiple of them. So the if is like really, really more open to what could happen, but the else if is really strict. So if I've got this chain of ifs and elses like this, format this correctly. If I have these chains of else ifs and this else, then I'm guaranteed that exactly one of these will run. So it depends whether you want only one thing to run and it's a decision between multiple things, or you want to say many of these things could possibly run. So I will split these up into separate if statements. So it's kind of like, are they packaged together or are they separate? Separate if statements are separate and they can all run. If you do the if-else chain, it's in one package in a sense, and only one of them will go. Oh, Jason's saying there are 5 reflections, so I think they are set up. So we use the model with one every 2 weeks, I think. Blank was asking, is if-else and else-if the same thing? Kind of, but not quite, right? Because else-if has a specific purpose. It's saying else says that if this thing failed, then the else goes, and then it starts running this if. If we say if-else, it's like saying there's the if and there's an else afterwards. So it's like the order of them will change how it works. Thank you, Tov. That's very nice to hear. There's a lot of thank yous at the end of the lecture, so thank you everyone for thanking. There's a question about bonus marks or the challenges. I think I've already answered that one. Holly's asking how the reflections they'll be marked. They'll be marked in, well, not in person. It depends if you're online or in person. They'll be marked with your tutor. So basically, most people are, if they're doing their reflections, you're just going to get full marks. If you're going over and above in your reflections, you'll get some bonus marks as well. If you're not quite doing enough in the reflections, then you'll get a lower mark, just to let you know that maybe there's more stuff that you need to think about. But basically, it's not an assessed exercise as much as it is a participation exercise, because the value you're getting out of it is the fact that you're doing it and you're having a conversation with your tutor, as opposed to something like an assignment where your mark comes back and your mark is nearly literally telling you how well you've understood what's in the course. Sorry, I just needed to set the code back, because I don't know when people are downloading this code. Yeah. So I may have written code at different times in here that doesn't actually run. Oh, Caleb was going through the style guide and asking about switch statements. Switch statements are super weird because they flow of the code in the way that we're writing in the course, C code, is very specific with how it works with the curly brackets sections and the flow of one thing to the next. Switch statements go a little weird on that because they jump to different things not via this format of doing what's in the curly brackets or jumping over to the end of the curly brackets with the if-else and stuff, and so they make it a little bit subtly different and awkward to read when they don't functionally do anything different than a series of if-else statements. So they have to be written in a format which is unnecessary for your learning of the understanding of programming as it is. Of course they're used, and they're used in industry and stuff like that, but for us to do that, it's the same reason why, if you know other stuff about programming already, why we're not going to use for loops in the course, because a while loop does everything that a for loop can. It's just setup is slightly different, the syntax is slightly different, and there's no point learning two different translations of how to do something when we're trying to focus on, okay, what is it like to learn about computer science, in a sense. So it's kind of like economizing how much difficulty you put into people's brains. So there's going to be plenty of people who will eventually learn that there are 18 different ways to do any one thing in C. For example, the printf and scanf can be done in different ways. Some of those we are going to have to learn because they've got more capabilities than what we've been doing here. But a lot of the things that are multiple different ways of doing the same thing, in the course we're going to pick one that fits into the format in the easiest way and is the easiest way to learn, so that we can concentrate on the idea of how to use these things, rather than saying, okay, here's an idea and here's 8 different ways of doing it, which is just going to confuse people, I think. So that's why things like switch statements are set aside for this course. So it's not like, it's like, if we're going to say we're teaching all of C in the course, then we would include stuff like that. But instead what we're teaching is like the fundamentals of learning programming, and we happen to be using part of C to teach it, which is why we're saying, okay, let's just cut off a lot of things on the side of the road and we just take this simple straight road through the middle that we can use. So I think I hopefully that answers your question about why the switch statements are out, because they've got weird stuff like break and those cases and stuff, which are just unnecessary to understand. They can come in handy later on if you want to learn it, but if you're trying to get to grips with what it means to be able to program, they're just extra stuff that it's kind of like you try to cram too much stuff into someone's brain, something falls out the sides, and if we try to cram in stuff like that, it's not necessary for people, and then something else that is necessary might get lost. Shrey's answered some questions there. Give refused something that you submitted, Caleb. Oh, did you submit something with a switch statement and it got refused? I think that would be the DCC enforcing the style guide at that point. Or was it you tried to submit the MOTD and then it was refused? Where am I up to? Sorry, I've just scrolled off where I was. George said, boo, orcs rule. I don't know how much you follow 40k and painters and stuff like that, but if you've ever seen this thing called the Inky Boys, which is a full black and white orcs diorama, that's something that I created a couple of years ago. It's cool because it's still like famous enough in Warhammer circles that it goes around and stuff. So I do love orcs as well, but I just can't be bothered painting that many miniatures. Okay, other questions. Do we need anything other than VLab on our home computing? Technically, you don't need anything else than VLab. So I'm going to teach the entire course on VLab unless my network connection crashes in the middle of a stream. But if my network connection crashes in the middle of the stream, you're not going to get anything from me. So, but VLab is the minimum necessary. So if you've only got VLab connected and you're not getting lag problems with it, you can continue using this for the whole course and you'll still get all the learning that I have intended for you to get out of it. DQNA64 is asking what kind of file is standard input-output.h. And Shrey bounced that one to me, so I will actually answer that one. It's actually a code file. Later on in the course, we are going to look at these .h files, which is a slightly different file to the .c files that we're using here. But it is a file that contains code that can be run, and what this file is, it's nearly like another file full of this kind of code that is cut and copy pasted right here into my code. So it has stuff that I can use. We're going to talk much more later about how that works and stuff. So bear with me. We'll go into detail later. But it's a good question, because basically any question that you ask, which is like, I'm going to cover this later in the course, is a perfect question, because you're thinking about, okay, what are the ramifications of these things? And I've also thought about those things and said, these are the things I want to teach. So your question's great, and it will be answered, but you will have to be patient, because it's going to be answered in a full lecture format with like formal slides and stuff, so I can really show you the concept. As Ricardo said, yes, it's called a library. We're going to go into those libraries. We're going to write some of our own libraries as well later. Kayla was asking if you can define a variable in Scanf. I think you mean declare a variable in Scanf, and I don't think you can declare a variable in Scanf. Oh, Alan's saying the link to read the code might not be working. I think it's because I haven't set up the permissions for the entire thing. Okay, I'm gonna do some serious Linux stuff here now. So this is the Linux permissions system. I'm not gonna go into detail on this stuff, but depending on what your capabilities are to do these things, the lecture 2 I think is the only thing that is available. Oh no, I need to do different things with this. I'll have to do it later, but I will set this up so that everything is visible. But for the moment, I think lecture 2 is the only thing that's visible, and my upper level directory is not visible because it's still me, not the web server that can access this. I'll change it later. But the link to lecture 2 will work, but everything else won't work for the moment. Shrey gave my answer to the can we declare a variable inside the scanf, was like, try to run it, see what happens. I think you may get an error when you try to compile that. Caleb's saying, makes sense. To clarify, I did an intro to programming course at UTS. Ah, right. Okay, so you've already seen a fair bit of programming, and I encourage you, because, like, you know, sure, there's a limit on what we're going to mark and what we're going to do in the course, but I encourage you to play around with these other things in your own time. And you can also go, like, look at our lab stuff and, like, do it in our format in the labs, and then as an exercise for yourself, go, I'm going to translate this into one of these other styles that I've learned, because that's actually something that we have to do as programmers, where we might work in a particular way instinctively, and it's always like we think about programmers having a native language, and my native language is C++, which is interesting because I'm teaching C here, so I need to, like, kind of, a lot of the time when I'm teaching C, I need to unlearn the things in my head that I keep trying to do, and one of them is the Camel case, which is the other way of doing variables like this. I do that instinctively because it's the first one I learnt, but I do think that this particular case is easier to read because it puts physical space in between the words. So I'm trying to really lock in and use only this in 1511. So if you've seen, I don't know if people go back and watch my other YouTube videos from previous terms, you'll see me switch between the cases, but this time we decided we're going to try to lock it down and just use only one, because it's kind of confusing to have the two. And so you get that kind of thing. So it's good to be able to sometimes have your native programming language, but also be able to work in others. Oh god, it's 6:45. I'm going to quickly go. Oh wait, there's not many questions left. Okay, good. Good. Okay, I'm just gonna cover up what's left and then wrap this up. I'm gonna have some dinner. And Shrey is saying to people, yeah, some of these things are going to get covered later. Shrey said week 4 for the and. I think is it week 4 or week 5 straight? We'll figure it out, But it is later and it's very complicated, so we're going to get to it once we've got more of a grounding to understand where we're going with that. Hussein's asking about practicing programming on the side. When you're at the early stages and you don't have you're not going to build up something big yet. I would take everything that we've asked you and try to make up versions of those questions that are different. So, for example, I did that here with these challenges. So I just came up with these things. I haven't necessarily coded them, but I'm pretty sure I could code them if it came to it. But you can probably think up other ideas here and other ways to put this thing together. And then when you come up with the idea and then you come in here and you start to try to code it, you'll see how you need to modify the code to make it work, and you get some really interesting results then. Sometimes you'll hit a point where you're like, I have no idea how to do this. So I tried to modify this for some special thing and I don't know how. And that's the point where you go, oh, there's some learning to do here. You go, okay, can we piece together these things in a different way? And sometimes you can, sometimes you can't. Sometimes it's worth talking to a tutor about it and say, look, I know this isn't part of the course, but I wanted to get more in depth in these if-else statements, so I did this. Can you look at it? You might get some useful help like that. All right, lots of answers from Shrey there. Shrey was like, please don't teach Linux permissions. Yeah. I started going in there and I was like, oh, no, we're just going to walk away from this one. I'll just do it later. Hussein's asking, how hard is it to switch between multiple languages, mainly Python and C? Hard, but not hard. It's like, I think there's this cool thing where you learn one programming language and you can work in that programming language. You learn a second programming language, you've learned to translate from one to the other. Now you can learn all programming languages. So it's hard, but it's a good thing, because once you can do it, it's never hard again. So you go, okay, I can jump between Python and C, and someone shows you Java and you're like, yeah, I can totally do that now. Because once you learn the basics of Java, you realize that 90% of programming is not actually the language. It's the thinking about how to solve the problem. Then you figure out how that language does it. So it's kind of like learning human communication and then learning individual languages. Like thinking about what you want to say is most of human communication, and then the language is just that tiny bit of transference of those things. So it's a bit like that. So it's hard to say exactly how hard it is. Yeah, and Matthew's answering that one as well, like thinking about the way that each language wants to do things. So it's kind of like if you can speak English and you learn to speak French, you understand that the grammar in French is different from English, and you start to learn that. Someone's saying flashbacks from drawing stuff in your lab. Yeah, you're right. That was not even a programming language, the drawing exercise that a lot of people will have done in their labs, or that kind of, your tutors will have done this thing where it's like, give them instructions and you have to do stuff. You start to learn the supreme difficulty in giving the right instructions, and that's the real key in programming. Like being able to write in a language is nothing compared to the difficulty of deciding exactly what to write, and that's the bigger picture with programming. Matthew, have you done some Haskell? Haskell is a programming language which is like inverted. It's super cool, super interesting. I've done a bit of Haskell in the past, and it's nearly like we go line by line in C. Haskell jumps in concepts, and so it's very, very interesting. Oh, Hussein, so you've done Python before, and so you're forgetting the semicolons in C. At least in C, if you forget a semicolon, your compiler will just pick it up for you. We're going to talk about that stuff later as well. I've got a lecture on debugging, which is about removing errors from code, and we'll look at that stuff as well. And there's COMP1511, as Shrey said, does Haskell. And someone was saying, yeah, Java is based on C. Again, this is why I'm teaching you C. Because nearly all of the other prominent languages were developed by people who learned C first. So it's very, very easy to jump from C to the other languages, because C is like the ancestor. It's kind of like the first fish that dragged itself out of water, and all mammals are based on that kind of thing. It's like that. C's the first programming language of that era. Obviously, not counting all the ones before it. It's the one that spawned the sort of, I guess, current epoch of high-level programming languages. I have to be really careful when I say stuff like that, right? Because C is obviously not the first programming language. There's obviously an A and a B before you get to C. They're real languages, by the way. And it's not the precursor to all languages, but it has a strong influence over the programming world nowadays. Okay, A doesn't exist? Or was it B exists? No, something exists to do with A. Anyway, I could just be talking out of my ass here. Anyway, I will wrap it up there. I've gone way over time with questions, but happy to answer a lot of questions here because I think people have a lot of interesting things they want to know about. Okay, I will call it there. Thank you all. Just to remind everyone, if you want to continue working on the labs at all, they're due Monday 8 p.m. I should have a course notice that I will send out to everyone on Monday before that's due anyway, just reminding people of that. Shrey was saying there's an A+. There is an A. I thought there was an A. I know that there's definitely a B. Yeah, anyway, whatever. We can always look it up later. I was just, like, pulling that out of my memory, so whether it was correct or not, I don't really know. Okay, see you all. Oh, Shrey's got the chain of development of languages there that led to C. But anyway, let's wrap it up there. Good night all, and I'll see you on Wednesday.